Hello, I'm Greg. Welcome to my channel, Midnight Oil Software. In this video, I'm going to teach you how to make the classic arcade game Joust. If you've ever wanted to learn how to make an arcade game using Unity, then grab your favorite beverage, pull up a chair, and follow along as I teach you how to write Joust in Unity. The very first thing you're going to need to do to make a game in Unity is install Unity. And you have to go up to Unity's webpage here, and if you haven't already, make sure you create a Unity ID. If you already have one, just go ahead and sign in, and then download Unity Hub for Windows. Or if you're on a Mac, you're going to want to get the version for the Mac, and so forth. Now, once you have Unity Hub downloaded, you also want to make sure you've got a version of Unity installed, and I'm going to be using 2021.3.23F1, the LTS version, which is long-term support of Unity for this project. So once you have all that, on the Projects tab, click this New Project button, and I'm going to call this Joust, and I'm going to put it in my Tutorials folder, and you're going to want to pick a template. And we're going to be using 2D URP Core because this is a 2D game. And all this does, by selecting this template, is it's going to install the packages that we need for a 2D game using the Universal Render Pipeline, which is what we want to use for our game. Once you've selected all that, click Create Project, and Unity will do its thing, and that'll take a little while, so I'm going to pause the video and come back when that's done. And we're back. And as you can see, we have created a Unity project, and it opens up into a blank editor here with a sample scene. Now I'm going to give you a little overview of the editor so you can know your way around. On the left here, we have the scene hierarchy. This is the hierarchy of objects that are in our current scene, this sample scene. Down here, we have our project structure, and everything we care about is going to be under assets. And I'm going to be adding some more folders to this in a minute and organizing things a little bit. This is our scene view, and this is where we see objects in the scene and allows us to arrange things and design our levels. And this is the game view. This is basically what the camera sees and what the player would see while they're playing the game. Over here is the inspector. When you select something in the hierarchy, it displays details about it in the inspector. And so you can see this is a camera, and every game object in Unity has a transform. The transform is its position, rotation, and scale. And then because it's a camera, there's some other properties that are specific to a camera. And objects can have lots of different components on it. So in this case, our camera has an audio listener, which is how you would play sounds. If you don't have at least one audio listener in your game, you're not going to have any sound from it. It's also got this script that it added as part of the template that I created. Now, one thing that I like to do is I like to organize things so that I can easily see stuff on the screen while I'm debugging and testing. And for instance, you notice that the hierarchy is all the way on the other side of the screen from the inspector. So one thing I like to do is take the inspector and just drag it over here next to my hierarchy. So it looks like that. The other thing I like to do is take my project and dock it underneath of my hierarchy like so. So now I've got a little bit more real estate here. And I like to take my scene view and dock it next to my game view, so I can see both of them at the same time. So this is just one of the ways I like to work. And I change my mind every so often, and I'll try different arrangements, but this works pretty well for me. The other thing I want to do is lay out our project structure. And like I said, this is not critical. Unity is smart enough to know where things are if you move them around. But this is just for me to help organize things so I know where to go to find stuff when I want to change it. So I'm going to take this little slider here, and I'm going to slide it down so I just see things with the names instead of those big old icons. All right, and I'm going to start creating some folders. Oh, before I do that, I want to rename the scene. I'm going to rename it and call it Title. So now we have a title scene. And let's add some more folders. So first thing I want to do is here under Assets, I want to create a new folder and I want to put an underscore in front of it and call it Joust. All right, so this is going to be my parent folder for all the assets that are specific to my Joust game. And I'm going to take the scenes folder and drag it into there. So now if we expand that, you have Joust, and under it you have scenes. Okay, now I want to create several more folders in this assets folder. I'm going to right click, create folder, and I'm going to create one called animations. And I'm going to go in there and I'm going to create 3 more folders. I'm going to create a folder called egg. I'm going to create a folder called enemy animations. And I'm going to create a folder called player animations. And let me go ahead and be consistent in my capitalization. All right, now up here in the Joust folder, I want to create another folder and call it art. And this is where I'm going to put our art assets. I'm going to create a folder and call it audio, and that's where I'm going to put my sound files. This game doesn't have any music, so it's just going to be sound effects. I'm going to create a fonts folder. I'm actually only going to have one font I'm putting in there. Let's see, I want a prefabs folder. And I want a scene, well, you already have a scenes folder. I want a scripts folder. And I think that's pretty much all I need, except I'm going to create some subfolders under scripts. I'm going to create one called input. I'm going to create one called managers. And I'm going to create one called UI. Okay, so there is our folder structure for our project. The next thing I want to do is import all of the assets that I'm going to be using in this project. Now, all of these assets are free, but only for personal use for the most part. I got most of them from a website by a guy named Sean Riddle. He captured them, I guess, from an arcade version of the game. He didn't have all the sprites that I needed, so I did capture some myself and some sounds as well from actual gameplay. And the arcade font I got from this 1001 free fonts. I also believe that's only free for personal use. If you want to use it for commercial use, you should reach out to him to talk about licensing. But at any rate, be aware that I don't believe that we have rights to use these commercially, but since I'm just using it for educational purposes as part of a tutorial, we should be fine. But at any rate, all of these assets are available on my GitLab, and I have a link to it in the description, so you can just go to there and grab it, and you can just pull it right into your project the way I'm about to do now. And also, by the way, all of the source code for this entire project is on GitLab as well, so you can grab it and compare it with what you're writing, or if you just want to get it and play around with it, that's fine too. So as far as importing goes, I've already downloaded them here, so I'm going to take all of the files from the art folder, and I am just going to copy them right there. And then I'm going to take all of the files from the audio folder and copy them into the audio. And up here under fonts, I'm just going to drag that arcade font and throw that in there. So now we have imported all of the assets that we need for this project. One thing I want to do is come in here to the art folder, and I want to select all of these images, and I want to change their max size to 512. They don't need to be that big. They'll look just fine down at that resolution. The other thing we want to do is this Joust Sprites. It's a nice transparent image. And it's a beautiful sprite sheet. If I was to double click this and open it up in an image viewer, you can see we got all of these little individual sprites that we can use in the game. However, if we were to take that and expand it, it's just one big image. What we want are all of the little individual sprites so we can select them individually. So the way you do that is we'll come over here and click the sprite editor. Well, before we do that, we want to change the sprite mode from single to multiple. And then click this sprite editor. And then we want to click slice. Make sure automatic is selected and click slice again. And you can see it's got these little rectangles that's put around all of these guys to indicate that they are individual sprites. And click apply. All right, now if we go back down into here and expand this, you can see we've got a bunch of individual sprites, which is exactly what we want. So I want to start off by making our title screen. Often I do the gameplay first, and then I do the title and game over screen as sort of an afterthought. In this tutorial, I'm going to start with the title screen, and it's going to allow us to go ahead and get our user input set up and our Text Mesh Pro stuff set up. So I'm going to start out by, I'm going to right click here and I'm going to add a UI image, which right away creates a canvas for us. And I want to go over to this canvas and I want to change the scaler from constant pixel size to scale with screen size. And I'm actually going to give this sort of an odd resolution. And the reason that I'm going to do that is I'll show you later. I have an image that I'm going to use for a reference image for when I lay out our level. And the dimensions of this image are 1301 by 979. And so I'm just going to go ahead and base our entire resolution on that. I'm going to say 1301 by 979. And the other thing I'm going to do is I'm going to go over to our game view, and here where it says free aspect, I'm going to set that to 1301 by 979. So our image here, I'm going to drag this Joust logo into this source image field. And that gives us that. And the way UI stuff works in Unity, you get a rect transform. And if you click on this little box up here, you can anchor this UI element to different parts of your screen. So I'm going to hold down the Alt key and I'm going to click here to anchor it to the top middle. And then I'm going to click this button here to stretch it, holding down Alt. And the other thing I'm going to do is I'm going to take this resize tool here. I'm going to double click this to select it in our scene view. And I'm just going to drag that down until I think it looks good. And I'm going to give it a little bit of padding on the edges. So let's try 10 by 10. That just gets it a little bit away from the edges. The other thing I want to do is got this ugly blue background. That's coming from the camera. So if I select the camera and expand it here in the inspector and we scroll down to environment, right here, it's already set to solid color, but we're going to click this background here and just drag it all the way down to black. So now we've got this nice black background with our Joust logo, and I'm actually going to drag it down just a little bit. I kind of like that. So now that we've got that, we want to actually add some text to our game. So here under Canvas, I'm going to right click UI Text Mesh Pro. Now, because this is the first time we're importing or adding a Text Mesh Pro object, it wants us to import the Text Mesh Pro Essentials, and we're going to want to import the Text Mesh Pro Examples and Extras. And this will allow us to create our fonts and stuff that we want to use for Text Mesh Pro as well. Okay, so that finished importing. Now I'm going to rename this, where it says image, I'm going to rename that to logo. I just like things to be named for what they actually are, just so it's nice and descriptive. And then I'm going to rename this to tutorial, title, I guess. And down here, I'm going to write Unity tutorial by Midnight Oil Software. Now that's pretty hideous looking. One thing we want to do, we need to create our font. So we go into our fonts folder here. We've got this arcade font that we've imported, but it's not a Text Mesh Pro font. So what we're going to do is we're going to right click on this and we're going to say create and then scroll down until we find Text Mesh Pro and then say font asset. And there we go. We've got a Text Mesh Pro font asset. And we are going to get a bunch of warnings, by the way, throughout this tutorial where apparently there's some characters that weren't defined in this font, and Text Mesh Pro is going to complain about it, but it's not a problem. So if I select this, and down here where it says font, if I just drag that arcade font in there, we now have a nice arcade font. And for color, I'm going to take this little eyedropper and click in that yellow there. So we're making that yellow. All right, so that's very nice. It still looks hideous though. So what can we do about that so that it doesn't look so hideous? Well, for one thing, I'm going to double the font size to 72. And then I'm going to tell it to be centered, and I'm going to use cap line for vertical. And then I'm going to turn off overflow or wrapping. So now we have a nice centered logo or title in the middle of our screen. I think that looks nice. Okay, we're going to duplicate this. So I'm going to select that and hit Control D. And I'm going to call this press flap to play. And that's exactly what I'm going to write in here. Press flap to play. And then I'm actually going to anchor both of these centered. They already are. That's good. Okay, so now I'm going to select the Move tool and drag that down about there. And I'm going to take the eyedropper tool and I'm going to click this red color here. And I actually want it to be brighter than that. So let's take that and I think that looks pretty good. So now we have a nice title screen. The next thing we're going to want to do is implement the user input so that you can actually press flap to play. So in order to handle the input, I'm going to create a script and I'm going to add it to this canvas here. This is going to be our title screen. I'm going to go into our scripts folder and under UI, I'm going to right click, create C# script, and I'm going to call this title screen UI. Let Unity think about that. Whenever you add a new script, it always has to think. And there we go. I'm going to drag that script onto our canvas. So if I select that, you can see I now have the title screen UI script. If I double click that, it opens it up, and I am using the Rider editor. So let me go back into Unity and show you under Edit, Preferences, External Tools. You can see my external script editor is Rider. If you're using Visual Studio or Visual Studio Code, it's going to open that up instead of Rider. But I like to use Rider just because it has some really good Unity integration and I have some good plugins for it. But you can use Visual Studio or Visual Studio Code. It works just as well. Some of the commands might be a little bit different, so I'll try and call that out when I can think of it. But I'm going to go back into here. And you notice there's all this gray stuff here. This is what we call boilerplate code. This is what Unity always adds when you first create a new script, unless you do what I often do, which is go into the script template and edit it to remove this stuff. What you usually see is in tutorials is they will go ahead and delete this boilerplate code. So they're starting from scratch. So I'm going to zoom in here so you can see what I'm doing. And I also want to turn off my GitHub Copilot because it is going to suggest some things and I don't want it to do that yet. I want to be able to just write this from scratch so you can follow along and not be confused by GitHub Copilot suggesting a whole bunch of autocomplete stuff. So I'm going to start with the serialized field, and this is going to be our input manager. And I'm going to create a class here. It's going to be an abstract base class because I'm going to have two different types of input managers. I'm going to have one for the player, which is going to use my controller, my Xbox controller, or the mouse and keyboard. So it's going to support both, either or. But the enemy input controller is going to be AI. I'm just going to use the same base class, And they're both going to implement an interface. That's just defining the contract for the input manager. And this way I can use the same movement script, whether you're a player or an enemy, and it will react to the controls and doesn't know whether it's a human pressing a button or whether it's the AI telling it it's pressing a button. So anyway, that's a long-winded explanation for why I'm about to create this base class. And I'm going to call it Input Manager Base. And I'm going to call that Input Manager. Now that class does not exist. So I'm going to come down here and actually I'm going to leave that undefined for now because I'm going to put that in the input folder under scripts. So I'm going to have a enable method. So by the way, I want to point out this script derives from mono behavior. All Unity components are mono behaviors, and they have a number of functions that are just built in. So this is going to be called by the Unity game engine when this object first becomes enabled and active. Okay, so or whenever it becomes enabled and active. And so what I want to do in here is I want to subscribe to an event. And I want to subscribe specifically to the on flap event. Because if you remember, the text for our title screen said press flap to play. So I want to know when the user presses flap. And so the way I'm going to do that is I'm going to say input manager.input manager. And this will make sense when I actually create that class. And then I'm going to say on flap pressed plus equal to subscribe to the event on flap pressed. All right. And then I want to unsubscribe from that and on disable. So I'm going to copy this line and I'm going to say on disable. And I'm going to paste that line right there. And then I'm going to change this plus sign to a minus sign. Sometimes I forget to do that. I just copy and paste it and I never unsubscribe. Now, having done that, I want to implement our on flap pressed function on flap pressed. And all I'm going to do in here is I'm going to load the game scene, which doesn't exist yet. Load scene game. And I'm going to tell it I want to load it single, not additive. And yeah, it's telling me there's no scene with that name in the project. And that's right, because I haven't created yet. All right, so I'm going to go ahead and delete this system namespace using statement. So by the way, I want to point out it automatically added this using statement for scene management. You need this in order to call scene manager.load scene. So just want to call that out. Let's go ahead and create this base class. And by the way, a serialized field is basically a field on the object that you can assign in the Unity editor. And I will show you that as soon as I create this base class. So jumping out into the Unity editor, if I hover over this, you can see why? Oh, because it can't compile that script yet because there's an error in it. So let's go into our input folder here, right click, create C# script, and I'm going to call this input manager base. And I'm going to double click that. And this is also a mono behavior. And I'm going to come in here and I'm going to say public interface I input manager. And it's just going to have a property. Actually, it's going to be the contract. So it's going to have a movement property, vector2. So vector2 is basically an XY coordinate movement. And that's just going to be a getter. And then 2 events. So we're going to need to make sure that we have the Unity events namespace. And I bet you it will try and add it for me if I just do this. Event action vector2 on move received. Oh, and it's actually in the system namespace. All right. Okay, so we have that, and then I want to add an action on flap pressed. So that is our contract, and I want to have a property here for our input manager base that's going to grab this interface off of the component. And the reason I'm doing it this way, this is kind of confusing, but there's a reason behind there's a method to my madness. I want to be able to assign the input controller or the input manager in the inspector, but Unity won't let me assign an interface in the inspector. So instead, I'm going to assign a base class, but I'm actually going to use the interface when I'm trying to access the input manager, and I'm going to do that by having a little helper property here that's going to return that input manager. So I'm going to first of all have a private property here, input manager or private field, and then I'm just going to get rid of these guys here. So I'm going to have a little public helper function here, public input manager, and I'm going to do a null coalescing statement here. Basically, if input manager is null, I'm going to call get component and get it. Otherwise, I'm just going to return it. And this is sort of a shorthanded way to do all that. I'm going to say input manager, and this is the null coalescing statement here. So if it's null, it's going to do this. It's going to say get component input manager. Otherwise, it's just going to return it because I've already gotten it. So the very first time I try to get it through this, it's going to go get it with get component and then return it. Otherwise, it's just going to return whatever value I've stashed in there. Go ahead and get rid of these unused using directives. And then I'm going to right click. And this is one where I'm not sure what the command is in Visual Studio or Visual Studio Code, but I'm just going to say refactor move. There should be something comparable. What happens if I hit Alt-Enter? Yeah, so this might work in Visual Studio. I'm just going to move that to its own file. And so there you go. If we jump back out into the Unity editor, you should see it appear right in here. And there it is. So going back up here, I now have this serialized field here. But I don't have anything to put in there yet. And the reason is I have not yet created my player input manager. So I think it's time that we do that. I'm going to right click here, create C# script, player input manager. And I'm going to double click that. And I'm going to get rid of all this boilerplate code. And instead of deriving from mono behavior, I'm going to derive from input manager base, and I'm going to implement the input manager interface. And I get all this error here because I have not implemented those interface members. So if I put my cursor there and hit that, there we go, implement missing members. And I think the same thing would happen if I hit Alt-Enter. Implement missing members. I want to implement all three of them, and there we go. Unfortunately, they're not doing anything yet, so I want to make this a private setter. And I always like to initialize my events to an empty delegate, so that if I call them and no one subscribed to them, I don't get an error. And here we go. All right. So we're going to need to set up our player input actions now using the new Unity input system. And so in order to do that, we need to jump back out into the Unity editor and do a few things. I can go ahead and write this code though, and then I'll explain how it's going to be called from the new Unity input system. So we're going to have move and flap as the two main actions that we're providing through the input system. And so the Unity input system is going to call a function called onMove whenever I move the joystick or if I use the A and D key on the keyboard. and it's going to pass in an input value from which I can get the vector 2 representing the movement. So I actually can't write this yet because I need to set up the Unity input system and it doesn't know what this input value is. So I'll write this and then I'll comment it out. So movement will be value.get vector 2, and then I'm going to call that event on move received, and I'm going to pass in movement. So a subscriber can get notified whenever we get a move event, but they can also directly read the movement value from this property here. And I'm going to do the same thing for on flap, except there's no parameter, and I'm just going to call the event. All right, let's comment this out, save that, and jump back out into the Unity editor and set up our Unity input system. So let's open up the Windows Package Manager, and we're going to look at Unity Registry and type in input, and here's input system, and we want to install the new Unity input system, which will take a few minutes. I'll pause the video and come back when that's done. Okay, so we are back. Unity has installed the new Unity input system, and now it says we need to restart the editor to enable the backend. So we will do that. And when it restarts, I'll restart the video. Okay, we're back. So I'm going to go ahead and close the package manager, and I'm going to add a player input component here. And for some reason, Unity is giving me an error when I try and create a new input action. I don't understand this error. I tried to Google it and I couldn't find anything about it. So what I'm going to do is I'm going to go down into the input system plugins folder. And I'm going to take this default input actions. I'm going to click edit, copy, or I could just do Control C. Going to collapse that, come back up into our input folder, and I am going to Control V to paste it. And then I'm going to rename that to Joust tutorial. So now we have a set of input actions called Joust tutorial. And if I go back into here, I can select that as my input actions. Now, there's a whole lot of actions that we don't want on there, so let's open this up. We're not going to have look, so I'm going to delete that. And we're not going to have this UI, so I'm going to delete that. So in here, our player action map, we have move and fire. And I'm going to rename fire to flap. All right, and now let's look at our move. So we have left stick, which is good. That's what I'm going to use for my gamepad, and it's only used in the gamepad scheme. And we have WASD for the keyboard, so that's fine. I'm going to leave that as is. And that's only for the keyboard and mouse scheme, so that's good. Now, I do want to get rid of these extra ones that we don't need. And if we look at flap, I don't want to use the right trigger. What I actually want to use on my gamepad is the A button, which I think is button south. So what I'm actually going to do here is under binding, I'm going to tell it to listen. And I'm going to press that button, and there it is, button south. So I'll click that, and that's only for the gamepad. And I'm also going to leave for left button on the mouse, so you can use the mouse if you want. And I'll just delete these extra ones that I don't need. So we've got move and we've got flap. Now I do want to add another one, and that's going to be quit. And the binding, we'll do a listen again, and I'm going to use the X button, which is button west on the gamepad. And I'm also going to add another binding, and I can't listen because I'm going to use the escape key. So under keyboard and mouse, I'm going to drop this down, keyboard, and then by location, escape. So now we have the escape key and the X button on the gamepad, which we only want for gamepad. So there we got gamepad and keyboard for move, flap, and click. I'm going to save asset and then check autosave. So if we make any changes in the future, they will be saved. Now I want to come back over and look at this, and I want you to notice that this is set to send messages. So basically every time we have a control input, either on the keyboard or the gamepad, it's going to call one of these functions. It's going to call on move, on flap, or on quit. And we also have it set to auto switch, and we can use any scheme. We could hard code it to keyboard, mouse, or gamepad. We're going to let it automatically determine what type of scheme we're using, and it will automatically switch. So if I hit the key, it'll switch to keyboard. If I press a control on the gamepad, it'll switch over to the gamepad. So we've got all that wired up for our input system. Which reminds me, I want to go back into our player input manager script, and I want to add another event here. On quit pressed. And down here, we'll say void on quit pressed. The only other thing I want to do is uncomment this and import the input system namespace. So there, our user input is pretty much all set up now. So that means if we go back into our title screen, we can select Player Input Manager component, and then right up here where we have our Input Manager, I can just drag that right in there. So there we go. We've got our Player Input Manager as our input for our title screen, and when on flap is pressed, it should load the game scene, which of course does not exist yet. So let's go back out into Unity, and we'll go into our, let's save this scene. So I hit Control S to save, and I always like to save my project occasionally in case Unity crashes. So under scenes, I'm going to right click, create, and scroll down until we find scene. And we're going to call this game. All right. And if we double click that, you'll see we've just got a camera, and that's good enough for now. So let's go to our build settings. If you don't have the scenes in your build settings, you can't load them. So right now we've only got the title scene. So I'll click add open scenes, and now we've got game. So I will click save. Go back to our title scene, and let's test this. I'm going to hit play, and then I'm going to press the flap button or the A button on my gamepad, and it should take us into our game scene. So we're playing. I hit flap, and there we go. We're in our game scene. Let me do that again, but this time I'm going to hit, I don't think I actually specified the correct control for flap in our input. So let me go look at that again real quick. I didn't add a keyboard control for flap, so I want to do that. Let's add another binding. And this time I will say listen, and I'm just going to hit space. So there, that's for keyboard and mouse. So we got keyboard, mouse. Both of these are keyboard, mouse. And then we have the gamepad. All right, let me test this again, but this time I'm going to hit the space key. And that worked. And we'll do it one more time, but I'm going to hit the left mouse button. And there it goes. All the flap keys controls are working correctly. So let's start working on our game scene. One thing I always like to do is organize things in my hierarchy here. So where I have main camera, I'm going to right click, create empty, and I'm going to call this camera and light. And I'm going to drag our main camera into there. And I'm going to add a global light 2D. I'll just rename that to Global Light 2D. And I will move that into that camera and light. And when it creates an event system, I'm going to drag that up there as well. I want to create another group here for our background. And I want to create one for managers. And I want to create one for UI. And as I add things to the scene, I will group them into these little parent folders. You can call them folders. They're not really folders. They're just game objects, but it helped me to organize things and keep things from getting cluttered in the hierarchy. Under managers, I actually want to start with a sound manager. So I'm going to right click here and say create empty, and I'm going to call this sound manager. And then down in our scripts managers folder, I will create a new script, and I will call that sound manager. Let Unity recompile, and then I will drag that script onto that object, and then double click to open it up in the editor. Zoom in, and I will go ahead and get rid of this boilerplate. Now, one thing I want to do, this is going to be a singleton, and I'm going to, instead of deriving from mono behavior, I'm going to create a new class, and I'm going to call it singleton mono behavior. So I'll declare that down here. I will say public class singleton mono behavior, and it's going to be generic. So this little T inside these less than greater than sign means this is a generic, and I can put any type in here, except that I'm going to qualify it. So it will itself derive from mono behavior, and T must also be a mono behavior. So that's what I said, I'm going to qualify it. Okay, so we're going to start with a public static T instance property, and it's going to have a public getter and a private setter. And this is basically going to allow us to reference this class or any derived classes from anywhere in our project just through this instance variable. And we're going to assign this in awake, and this is going to be a protected virtual void. And the reason I'm making it protected and virtual is because I want to be able to override this in the derived classes in case I want to do anything extra in addition to what we're about to do in here. And so what we're going to do in here is we only want there to ever be one of these. And so what I'm going to do is I'm going to check to see if that instance variable is not equal to null and whether it doesn't equal to the component that we're actually creating here. And if it does, then that means that somehow we're creating an additional one and we want to just delete this one and go with the original one. So I'm going to say if instance is not equal to null and instance is not equal to get component T, then we want to destroy the game object and return. Otherwise, we are going to assign get component T to our instance. And the only other thing I need to do is I need to move it into its own class. So I'm going to hit Alt Enter and say move to singleton monobehavior.cs. All right, so we have a sound manager that is a singleton, which means it can be accessed anywhere in our project by just calling soundmanager.instance. So what do we want to do with that? Well, I want to have a bunch of serialized fields for the different audio clips that we can play. So I want to have audio clip, flap sound, thud sound, skid sound, and run sound. And let's keep these lines from getting too long. I'll start another one. And how about egg sound, start sound, kill sound, pterodactyl sound. Hey, I think I spelled that right. And we'll do another line. audio clip, free man sound, or I guess I could call it extra man sound. It doesn't really matter. The other thing I want to do is I want this guy to always have an audio source. So I'm going to say require component type of audio source. And I'm going to override our awake method. So I'll say protected, override, awake. It will call the base class awake, and then we will say our audio source equals get component audio source. And then I will alt enter, create field audio source. There. Now I'm going to turn GitHub Copilot on, and you're going to see the power of it. Based solely on the variables that I created here, in the fact that I've called this sound manager, I want you to see what GitHub Copilot does. Enable completions. Play audio clip. Well, sure, I'll add that. What else can it suggest? Play flap sound. Audio source, play one shot, flap sound. Yeah, I like that. What else? Play run sound. Play skid sound. Play thud sound. Play egg sound. Play start sound. Kill sound. Pterodactyl sound. I think that's it, isn't it? No, Freeman sound. Play, it's suggesting I add a play random sound. I'm not going to do that. All right, but I think you can see how much time you can save with GitHub Copilot auto-suggesting things. And I think it's interesting that it's adding volume parameters for these. I think it's because I did that in my prototype and it remembered that. So it's training itself based on what I've done in the past. So it's very, very interesting. It's basically combining AI with autocomplete. So it's just a glorified autocomplete, but I can see how that's really going to be a big time saver. But let's jump back out into the Unity editor. And we're going to see all those serialized fields appear here. And there they are. So if I go and I right click here and I say properties, it'll open that up in a window that won't go away as I select things in here. I'm going to go into our audio folder, and I'm thinking I'm missing a sound here because I see spawn. Maybe I don't play them through the sound manager. Or look, anyway, egg sound will be Joust egg. Flap will be the flap sound. Footstep will be the run sound. Free man will be the free man sound. Pterodactyl will be the pterodactyl sound. Skid will be the skid sound. Start will be the start sound. Kill for kill sound. Thunk for thud sound. And that's all of those. Nice. So now we have a sound manager and we can tell it to play any of these sounds on command. So jumping back down here into managers, I'm going to create a game manager class. Right click, create C# script, game manager. And up here I'm going to right click, create empty, game manager. Of course, Unity's busy thinking. Okay, there we go. I will drag game manager onto there. Open that up in the editor. Zoom in. I'll leave these here because I am going to have start and update. Actually, I'm not sure about update. I know I'm going to have start. Let me go ahead and get rid of update. What I want to do in start is I want to say sound manager dot instance dot play start sound, and I'll say start game, and I'll create that function. And that doesn't do anything yet, but if we go over to the Unity editor, go back to our title scene, I will hit play, and then I'll click the flat button, and it should switch to the game scene and play the start sound. I just want to go over to my OBS where I'm recording, and I want to see if I have my desktop audio being recorded, and it looks like I should, so let's go ahead and give this a test. And there we go. All right, so now let's start laying out our gameplay level. So switch back to our game scene. I want to get rid of this blue background, so we're going to go into our camera and scroll down to environment and change it from skybox to solid color and drag that all the way down to black like that. There we go. Nice. And we're going to go into our background here, and I'm going to add a reference image that's going to help us to lay out our level. So I will right click and say create empty, and I'm going to call this reference image. All right. I'm going to right click and go down to 2D object, sprite, square. So I'm going to create a sprite, but then for the sprite, I'm going to go to our art and say Joust screen and drag that right in there. And I'm going to scale that up a little bit, and that fills the screen. So that is the screen that we are going to want to replicate basically for our game. Now, one thing I had tried to do in my prototype was to use the platform sprites from this Joust sprites. So you've got these things here, like this guy here, and you can kind of see that would go here, it looks like. And if I was to, actually, I'm going to minimize the opacity of this guy just so that we can kind of see what we're putting on over top of it. But if I was to take this guy and drag him into the scene, right, and then try and position him up here and scale him up, you know, I could get him to fit there pretty good, but if I turn off that reference image, I didn't really like the way that looked. It didn't look so bad on this one, but when I got to some of the other ones, they just didn't pop, if that makes sense. There was a lot of transparency and stuff in it that I just did not think looked good. So what I ended up doing was taking this reference image and pulling it into Photoshop and cropping out the individual platforms. And I just think they look a lot better. So what I'm going to do is I'm going to collapse this image here. And you can see I've got all these different platforms here. I've got platform lower middle, platform middle high, middle left, and so forth and so forth. So like platform top left. I'm going to take this guy and I'm going to drag that right up there. And I think that looks pretty darn good. I'm going to nudge it over to the left just a little bit. Yeah, and so we've got that beautiful looking platform there. Let's see, so that was top left. How about platform right high? And they don't have to line up perfectly. One thing I want to do, though, it looks like you can go across the screen from one side to the other. I want to make sure these heights are the same. So we got, this is 2.226 something. I'm just going to copy that and I'm going to paste that. So they're at exactly the same height. So if you're walking across the screen, you come out this side, you come back in on this side, there won't be any difference in height. Okay, so I'm going to pause the video and I'm going to drag all these things on, and you can pause the video and do all that yourself and come back and we'll finish making this level. Okay, so we're back. The one thing I want to do is I want to put all of these on that background object so they're all children. So I can just collapse them and get them out of the way if I want. The other thing I want to do is I want to add box colliders to all of those guys. And they need to be the 2D version. And we can go in and adjust those to make sure that they're flush with the top, because you can see some of them are not. So let's take the top left. I'm going to zoom in here and click on the collider and just drag that down a tad. Okay, top right. I think that's fine. Maybe just a tad. Oh yeah. I think that disparity is just based on the way that I crop these in Photoshop. Let me turn off that reference image real quick. Okay, I think that looks pretty good. I want to add our ledges. So I've got this ledge image here, and it looks like I'm going to have to scale that up some. Actually, I want to rotate this 180 degrees on the y-axis. Yeah, that looks good. Okay, and I will move that up into the background, duplicate that, flip it to positive, and reposition it. It's interesting that the right ledge is farther away from the edge of the screen than the left edge is. I'm going to rotate that again 180 degrees, like that. And the reason I made those ledges separate is because on subsequent levels, like on the second level, this little tongue of flame comes up and burns this down. So you lose the ledge and you could actually fall into the lava. Oh, that reminds me. We need to add some lava to our background. So let me turn that reference image back on. And there's, you can see the lava. So what I'm going to do here is I'm just going to add a sprite square and move it down like so, resize it, and then go into its color picker. And actually, let me turn that reference image opacity back up again. So go back into this guy. I need to rename that to lava. There we go. Go take his color picker and pick that. And turn that reference image off. And there's our level. And I think it looks, ooh, but we want the lava to be behind this. So that's another thing I want to do. Let's take all of these guys. So they're at order level layer 0. That's fine. But I want to take the scoreboard and I want to set it at level 1. So that's in front. All right. Nice. So the next thing I want to do, I think, is work on the player bird. But I want to do a little cleanup first. I want to create an empty game object here, and I want to call it platforms. And I'm going to move all of these platforms into there. And then I want to create another one called ledges. And I'll move both the ledges into there. And I'm going to make this left ledge and right ledge. And then I'm just going to move them up to the top under the reference image. There. So nice and organized. Got our whole background. Underneath of that, I've got our platforms and our ledges, our scoreboard, and our lava. Okay. So by the way, the scoreboard was just this big thing on the bottom here. And this is where we're going to show our score and the number of lives that the player has left. So working on the player, I'm going to right-click, create empty, and create a new object called player. And underneath of him, I'm going to create a game object and call it Sprites and Animation. Let me go back up here to the parent. We're going to want to add a rigid body 2D, and we don't want him to have gravity because we're going to apply our own gravity, but in all other ways we do want him to respond to physics, except we want to constrain his rotation. So he can be knocked around, but he won't spin. So there, I think that'll be good so we can have some physics interaction. This is also a good time to go ahead and create all of our physics layers. So I'm going to drop down here, say add layer. I'm going to want a player layer, and I'm going to want the enemy bird layer, the egg layer, enemy knight. The enemy knight is after an egg hatches and he's down on the ground. A pterodactyl, the ground, enemy mount, and player mount. So if a player or an enemy gets unhorsed, if they get killed, so to speak, there's just an empty bird flying around. That's the mount. And we have different collision rules for them than we do for the player. And so one great way to minimize the amount of checks you got to do in code is to put things on different physics layers. And then we can go into the settings and set the physics collision matrix so that only certain layers only interact with certain other layers. So let's go up here to Edit, Project Settings, and we want to go find Physics 2D. And down here at the bottom, we've got this collision matrix. And right now, everything collides with everything else. So we're going to want to fix that. So first of all, the player mount should only collide with the ground. And I'm not going to sit here and painstakingly do this while I talk. So I'm going to go ahead and stop recording, set all these, and then come back and explain it to you. Okay, so we're back. Essentially, mounts should only collide with the ground. The ground should collide with birds, eggs, enemy knights, and pterodactyls. Players should collide with the ground, pterodactyls, enemy knights, eggs, and enemy birds. That's pretty much the only collisions we care about. Okay, so we can close that and get back to work on our player. So we've got a rigid body. We're also going to want to add our input. So first of all, let's add the player input component. We're going to want that, and we're going to want to set its actions to be the Joust tutorial actions. And we are going to add the player input manager script that we created. And we're going to want to create a new script, which is going to be called Bird Mover. And we're going to use the same script for the player as we do for the enemies. And the only difference is going to be what input controller they use. Because whether you're a player or an enemy, you flap, you move left and right. But whether you flap or move left or right depends on what controls are pressed, and then what controls are pressed can be controlled by what's behind the control. So there we go. That's the reason we architected it this way. So let's go into our scripts folder, right-click, create, C# script, and call this Bird Mover. Can't put a space in the script name. Let Unity compile that. And I'm going to drag that right up to here. And really the only thing I want to do right now is set up our input. So let's go ahead and get rid of the boilerplate for now, just so we're not so cluttered. And I want to zoom in so you can see what I'm doing. So I will add a serialized field, and I'm going to call this input manager base input manager. And so I want to show you how this works. If we go back out into the Unity editor, we'll see that field appear here. And I can just drag that right into there. And so this player object will be controlled by this player input manager. And I'm going to go ahead and create a prefab for that. So I'm going to drag the player right into our prefab folder. So I now have an object. If I was to delete this, I could just spawn a new player at any time, and it's got everything set up the way we want, except I forgot to put it on the player layer. So yes, I want to do that. And that reminds me, I want to go to our background here, to our platforms. All of these guys need to be on the ground layer. Yes, change children. The ledges also need to be on the ground layer. That's very important. Okay, so now I think we're ready to move on to adding a sprite renderer for this guy, and then we're going to want to create some animations for this guy. And we want to have specifically the run animation, the flap animation. We want to have an animation for when he's just standing still and when he's falling. But first, let's go ahead and add a sprite renderer. And then if we go and look in our art folder and expand the Joust sprites, zoom in a little bit here. For standing, the default sprite we want is this one right here. And I think that looks a little bit small. So I'm going to zoom him in like 2.5 times. That looks pretty darn good. And I can give him some colliders. Now the way I want to do this is I want to have 3 different colliders, because there's going to be a standing bird, there's going to be a flying bird, and there's going to be the knight who sits on the bird. And I want all 3 of them to have their own colliders. So it will sort of function as a compound collider. And the collisions will be handled by the layer that has the rigid body up here. But first, I'm going to create one just for standing bird. And I'll go ahead and put a space in that name. And the only thing that's going to contain is a box collider 2D. So I'll say add component, box collider 2D. And let's go ahead and zoom in on the scene view here. And I want to move this away from the camera. I could just turn the gizmos off. But I'll just move it up here. This would be a good test too to see if our collider works. So if we go down here and we select that collider, that's just way too big a collider. So let's go ahead and mess with that. All right, now what happens if I hit play? Oh, he doesn't fall because he's not responding to gravity. So if I go up here and I go into the rigid body and I set gravity scale to 1, he'll fall and then he stops on the platform. And like I mentioned before, we're going to have our own gravity. So we'll let that go back to 0 when I stop playing. So now we have a standing bird, and he has a box collider, and I can go ahead and add the knight to him and add a collider for the knight, and then we can work on the animations. So under sprites and animation, I'm going to right click, create empty. I'm going to call this a knight. I'm going to add a sprite renderer. I'm going to go and look for the yellow knight, this guy right here. And now I'm just going to position him a little bit. And I want the knight to be behind the bird, I think. So I'm going to take this guy and set his order and layer to be 2. And this guy, I'm going to set his order and layer to be 1. So I think that looks pretty darn good. So there is our player on his bird. Let's give him a box collider. Zoom in here. Let me turn my gizmos off in the scene view. Oh, that's the wrong one. There we go. Turn the gizmos off. So I got him. I will turn on our box collider here. And really, the knight, all I care about is his javelin. Right? I just want to know if he hit the other bird. I can make that a little bit bigger, I guess. All right. So now we have our knight sitting on our bird. Time to work on the animation. So to do the animations, we basically, let's do the run animation first. I'm going to take, for the blue bird, these 4 frames here, and that's going to be our run animation. All right, so I'm going to select them, all 4 of them, and I'm going to drag and drop them right there. And we're going to navigate to our animations, player animations folder. All right, so if we go into that folder, it also created an animation controller, but we don't want it to be called Sprites and Animation. So I'm going to rename that, and I'm going to call it Player Animation Controller. And so if we go and look at this node here, here's our sprite renderer. We now also have an animator that's using the Player Animation Controller. And I'm going to come down here, and I want to add a tab, Animation. And so I've selected that, and you see I've got this running animation. I want you to watch him. And you can see he is moving, animating. It was that easy to make a run animation. It's a little bit slow, so I'm going to speed that up a little bit. I think that looks a little bit better. Very nice. I'm very, very happy with that. Now, if we double click on this animation controller, we open up this animator window, and you can see we've got this running animation. Now, we don't want the running animation to always be on. We want to basically switch between different animation states, and we definitely don't want running to be the default state. So we're actually going to want to create another state, which I think should just be standing, and it's just essentially going to be that last frame that we used with this image here. So what I want to do is I want to create some parameters on this animation so that we can switch between states. So I know we're going to want to have a float for speed, and this is going to determine whether he's just standing still or running. I'm going to want to add a Boolean for are we flying, and this is going to basically be determined by whether or not we're grounded. So we're going to cover how to tell if something is grounded or not using raycast. I want to have a trigger called flap. So every time we press the flap key, we're going to set this trigger, which is going to trigger the flap animation. And then I want to have another Boolean for skidding. So we're going to have another animation that's just basically going to be, let's see, if I was to zoom in again, it's going to be this frame here if he's skidding. And so if he's not grounded, if he's falling, I think I'm going to use that image. And when he flaps, I'm going to do an animation from that to that, and then it'll go back to that. So let's go ahead and add those other animations. But before we add the other animations, there is something I wanted to do for the running animation. So one thing I think is really cool about animations in Unity, even 2D animations, is you can add what's called animation events. And you can have those events call functions. So what I'm going to do is on this sprites and animation guy here, I don't want to open a prefab, I want to add a script to it called footsteps. So I'm going to go into scripts, I'm going to right click, create, C# script, and I'm going to call it footsteps. I clicked off of it. Let me zoom out here. And I will rename that to footsteps and drag that onto the sprites and animation object on our player. I have to rename it in here too. Oops. Footsteps. All right. Jump back out into the Unity editor, let it recompile again. Drag that onto there. All right, and we're going to double click that, zoom in, and I want to have a public void function. Public void. There we go. GitHub Copilot remembers what I did in my prototype and is suggesting that I do that. Except this is going to be play run sound. All right. Let me go ahead and get rid of those unreferenced using statements. Go back out into the Unity editor. And let's look at our animation. We're going to step through it frame by frame. So we're on our run animation. I think that's the frame we want to play the footstep sound on. The foot's not quite on the ground yet. It's on the ground there. So what I do is I will click this little plus sign, add event. I'm going to double click that. And you see up here, no function selected. So it's looking for a function on the object that this animation is on. And look at that, play footstep sound. So now, if I was to hit play, and it should already be on the footstep animation. So it is playing the footstep sound and is synchronizing it on when that foot is actually pressed down on the ground. But there's another thing I need to do that I just remembered. When I switch between this sprite and the flying bird sprite, the sprites are different size, really. So if you look at this one, he's actually sitting lower than the body of the sprite here. It actually shifts down, and this will leave this knight floating in midair, which we do not want. So what I want to do is, when this sprite plays, I want to have this knight be at the position he's at now, which is 0.13 on the y-axis. So I'm going to come down here into our running sprite, running animation. I'm going to add a property, and I'm going to drill in here to the knight's transform position. So we're going to go ahead, and this is the position he's at, and that's the position we want him to stay at. So hopefully that does not change anything in the animation, but we're going to, when we add the flying animation, we're going to have a different position for the knight. So he's going to basically sink down with the bird as it transitions from running to flying. But let's switch to a standing animation now. So coming in here into our animator, I want to create a new state, and I'm going to rename it and call it standing. And I'm going to right click on that and say make default, set as default state. So I need to create a new animation for that. And so I think what I'm going to do is I'm going to go into our animation folder and I'm going to duplicate this. And I'm going to rename this standing. And I'm going to select standing here. All right, so that's now our default. Now let's go edit this. If we look at our standing sprite, and I'm going to delete that, I'm going to delete that, I'm going to delete that, I'm going to drag that, and delete that. So now if I hit play, he is just standing, and if I switch to running and hit play, we have running. Okay, so now we want to transition from standing to running. So I'm going to right click, make transition. I'm going to select the transition. It will have no exit time, no fixed duration. The transition duration is 0 seconds. All right, and then we're going to add a condition. Conditions. So I'm going to hit plus down here, and we want speed is greater than 0.1. All right, so now if I hit play, you see he's just standing. Oh, but I have that event on there still. I got to get rid of that event. But I'm going to take his speed and I'm going to crank it up. And you see he transitions to running. And if he slows down, I don't have any transition back, so he stays running. So let's go back into there and go back into our standing animation, and we want to get rid of this event. And there we go. Let's add a transition from running back to standing, and the condition will be no exit time, no fixed duration, no transition duration, but with the condition of speed is less than 0.1. So if I hit play, increase the speed, he starts running, and then he stops running. So we have transitions between standing and running. Now we can do skidding. I'm just going to duplicate standing, rename it to skidding, and let me rearrange things in here a little bit. I think I want standing to be down here, and I want running to be up here. And then I'm going to drag skidding up here. And so we'll have a transition from running to skidding. All right, and the condition for that, we don't want an exit time. We don't want a fixed duration. But the condition is going to be that skidding is true. All right, and then we're going to want to transition back to running. And the condition is going to be that speed is greater than 0.1, and add another condition where skidding is false. And then a transition from skidding to standing, where speed is going to be less than 0.1, and skidding is false. So we can give these some tests. Right now we're not moving at all. Give them some speed. And then I will say skidding. But I didn't edit the animation, so it doesn't look any different. All right, so select this guy, and we will select skidding, and then all we're going to do is change the sprite. So right now, the sprite that we're using is that guy. But we want to go into our art folder and replace it with this guy. All right, so if he is skidding, it switches to that animation. Perfect. All right, so now we want to have a flap animation. So I'm going to go back to our animations folder, and I am going to actually drag the art for that on there. So go back to our art folder, and the ones I want to use are this one and this one. So put this up here under animations, player animations, and I want to call that flapping. I want to reverse these. Yeah, I'm pretty sure I want this one to go first. So let me take this and put that there. And then I want to move this out a second. Have a little bit of a delay. And I'm going to switch to this one. And I think that's pretty much all I want in there. Now we want to add our night property. And I need to look, I think I wanted to put this at like 0.07 when we're on that one. So in order to switch to flapping, let me drop that down to here. We can go from standing to flapping, and our condition is going to basically be that flap is triggered. So give us some room in here. Make a transition, come in here, turn that off. We don't want that or that. And then the condition is flap. And then it will immediately go back. Well, then it's going to actually depend on whether or not we're grounded. So we're going to check this flying flag. So we're going to transition back to standing if we're not flying and our speed is less than 0.1. So it's going to play the whole animation, and then it will automatically go back to this if speed is less than 0.1 and flying is false. Otherwise, we need to have another animation for falling, which we don't have yet. But let me just go ahead and test this first. So I want to switch to flap. Oh, it looks like it played it. Oh, I need to turn off the loop time on it. So if we go into our animations folder and I select flapping, you see loop time is checked. We want to turn that off. So let's go back and try that again. Flap. And it just flapped once. But the night moves up. Oh, I think I need to edit the night's position all through the animation, not just in the first frame. Yeah, that looks kind of weird. Let's fix that. So we'll take this, come down into our flapping animation. And so here's our night's position. Well, that looks correct. That's really interesting. Let me go look at them in the running animation or the standing animation. It's just the one frame. There's just a weird delay in him moving back to that position. Let's give this another test. Yeah, that's weird. Okay, I have fixed it off camera. What I ended up doing was in the flapping animation, I just added an extra position for that Y position to be the same as what we started with, to make sure that after this guy finishes his last frame, he sits at that position long enough so during the transition, you don't notice the gap. And that seemed to work really well. So now for the falling animation, we're going to do basically the same thing. I'm going to take the standing one, duplicate it, rename it, call it falling. And I'm going to drag that onto our animator controller over here roughly. And so we transition to falling from a number of different conditions. Basically, if you run off the ledge, you fall. If you were standing and got knocked off the ledge, you'd fall. So we can basically go to it from standing, we can go to it from running, and we can go to it from flapping. We can even go to it from skidding. So pretty much every condition, every animating state can go to the falling state in one way or another. Let's do it from flapping first. So we're going to right click, make transition from flapping to falling. And I'm just going to set the exit time. I think all this is fine, actually. The only thing I really care about is if we're flying or not. So at the end of the flapping animation, if we are not grounded, if we're flying, we are going to be falling. So I'll just come down here and say add condition and say flying is true. So that one is simple enough. And of course, we can go from falling back to flapping by hitting the flap key. So we're going to do that. And we're just going to say, actually, this one we don't want an exit condition because we're going to go immediately from falling to flapping as soon as you press the flap key. So flap. All right, so there we go from flapping to falling and back. Let's go from running to falling. So basically, no exit time, no fixed duration. We're just going to go there if we are flying. And then the transition back is going to be very simple. It's basically going to be that our speed is greater than the 0.1 and we're no longer flying. And let's see, we want to be able to go from skidding to falling. And that's simply going to be if flying is true. And finally, from standing to falling. And back. So if our speed is less than 0.1 and we're no longer flying, then we will go to standing. So I think those are all the animation transitions that we need. Let's just give this a quick test. Did I actually create the falling animation though? I didn't, I just copied it. So we want to change our sprite. So we go to our art, zoom in here. We want this one. Oh. There we go. I'm editing the running animation. How do I always do that? Falling. There we go. And I want to do the same thing that I did when going from flapping to standing. I want to make sure that I have an extra frame with this position here. And I also want this to be 0.07. And we'll copy that, come over here and paste it. Let's see. There we go. So let's just play that animation and it doesn't change. That's perfect. So now let's go up here and give this a test. So we should go flap and then fall. Well, let's move him. Well, I'm not grounded, so I'm going to set flying to true. All right, now I'm going to flap, 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 and then if I'm no longer flying, I go to that. Perfect. And let's see, let's set our speed to 1, so we're running, but then I flap. I'll set flying, and I'll flap, flap, flap. No longer flying, and so we're running. All right, so the transitions all seem to be working correctly. So we now need to start writing a script to actually move the player and implement all that flapping and running and skidding and falling. Looking at this, I think I missed a transition. I want to go from flapping to running. The condition is going to be speed is greater than 0.1 and flying is false. Okay, good. And before I forget, I want to make sure I add the sound effect for the flap and the skidding to our animations. So we'll come back over here and we will pick the flapping animation here. And we're going to, right here at the first position, add an event. Now we need a new script for this. So if we go into our scripts folder, we'll create a new C# script. And I'm going to call this flap sound. And I'm going to create another one. And I'm going to call it skid sound while Unity's thinking. Alrighty, and I'm going to select our sprites and animation here. And when Unity's done, I'm going to drag both of those onto there. So we got our flap sound and we got our skid sound. Let's open that up in the editor and zoom in. Get rid of this boilerplate. And I'm going to have a public void play flap sound, and it will do a sound manager.instance.play flap sound. And I'll come up here and get rid of the unreferenced using statements, and I will save that, jump back out into the Unity editor, let that recompile, and then I'll do the same thing for skid sound. Zoom in. Get rid of the boilerplate. Hey, look at that. GitHub Copilot knows what I want to do based on what I just did. So I just hit Tab. It completes that. Let's get rid of these unused using statements. Jump back out into the Unity editor. So now, excuse me, now our sprites and animation object has those components on it. So if we go back to our animation here and pick the flapping, take this event here, I can say play flap sound. Control S to save. Let's change to our skidding animation. We'll add a new event and we'll say play skid sound. So now when we switch to those animations, they should play the appropriate sound effect when they start playing the animation. Let's start fleshing out our bird mover script a little bit. So we're going to add a few more serialized fields to this. Right now, all we've got is our input manager base. So let's take this and I'm going to turn off GitHub Copilot for now. So we can just do this the old-fashioned way. One thing I want to do is I want to be able to assign our animator. I could use Git component to get this, but I'm just going to go ahead and assign it in the inspector. Why not? If I can type serialized field, we want some floats for several parameters on this bird mover script. So first is our flap force, and we'll make that 1.5F. Our gravity, I'm going to go with a value of 2. Move speed, I'll start with the value of 3. A flap delay, we don't want them to just be able to spam the flap key, so we're going to have a little bit of a delay there. And let's go ahead and break this up to another line. We want a raycast distance to see if we're grounded. And let's see, 0.52F. That has to do with the height of our sprite, because we're going to be casting out from the middle of our sprite. And we want to have the amount of skid time. I'm going to go with 1.1 f-seconds, and that's really based mostly on the length of the audio clip that I play when we're skidding. All right, some more serialized fields. I want a layer mask, which is going to be our grounded mask, to determine what we're looking for in our raycast to tell if we're grounded or not. And our sprite renderer. So let's jump back out into the Unity engine and we will assign these variables. Let's go ahead and collapse some of these things. So we want our animator, which is going to come from this node here. These values we're going to leave at their defaults. Our grounded mask is going to be ground. Imagine that. And our sprite renderer is also going to come from there. Okay, so that's all looking good so far. One thing I want to do is I want to add another node here for flying bird. And that's where we're going to basically assign our box collider. So I will create empty, and I will call that flying bird. And I'm going to move that up above the night. Doesn't really matter, but it's just in my mind logically standing bird, flying bird, night. And all we're going to do is add a box collider 2D, switch to our scene view, and let's go ahead and click on that. And that's definitely not what we want. So I'm not even sure that's quite what we want. Let me just temporarily change the sprite that we're displaying here to be the flying sprite, which is, we'll use this one. Go back to our flying bird, pick our dude here. I think that looks pretty good. All right, so now we obviously want to switch this back. I think it was 27. Yes. Okay, good. So we got him straightened out. I'm going to override to apply all those changes to our prefab. And we've got all these variables assigned. Let's go back into our script and continue editing. So we're going to want to add a lot of variables to this code that we're going to use to handle when we flap and how long flaps last, how much velocity we apply, doing the ray casting, trigger animations. There's all kind of things that are going to be done from within this script. So I'm going to define a bunch of variables here. We're going to have our flap time, our current skid time, and I'm going ahead and adding all these in advance. They will make sense when we actually start using them. The speed factor, what we're going to use that for is it's really only applying to the enemies, because I'm using the same script for the player and the enemies. But as we increase in levels in the game, I want the enemies to get faster and faster. So I'm going to have the speed factor variable that we will apply to the velocity. So let's see, float, flap velocity, and move velocity. We want to use a non-allocating raycast. So I want to have pre-allocated array of raycast hits, and that wants to be an array, not in singular instance. I want to have a bool to say whether or not we're flapping. I think when I was testing, I had some issues where I might receive multiple inputs, and I need to know if I'm flapping before I try and flap again, basically. So we're going to have a little flag for that. I want to know what our current direction is. I want to know whether or not we're skidding. And then I'm going to pre-allocate a bunch of hash keys for the animator states. So for the parameters, actually, for the animator, just for performance. So we're going to do a static read-only int flapping, and I'm going to use the animator string to hash flap, static read-only int flying, animator string to hash flying. I'm going to do one for speed. And one for skidding. All right, just double check those. Those all look good. And finally, when we spawn a player or an enemy, there's going to be a period of time when they're invulnerable. So I want to have a flag for that as well. And then I want to have a little helper property here, can flap. This is basically going to be looking at whether or not we're skidding and then whether or not we've elapsed our flap time. Like I mentioned, I don't want them to be able to spam the flap key. So this is an expression body method. So I'm doing this little greater than equal than, greater than equal to. And what all this is going to do is it's going to execute this code here and return it as a Boolean. So the expression is going to be, we're not skidding, and time.time is greater than or equal to flap time. Now, this expression body method is basically a shorthand way of doing a property getter. So hopefully that makes sense to you. If I wanted to, I could refactor that. I could do toStatement body, and that would actually refactor it to be an actual property getter, which is longhand like that, but we're going to switch that back to an expression body. Just like that. There you go. So, little detour there just to explain expression body methods. I want to have a shortcut to our input manager. Remember, we're going to use the interface for our input manager, because that has the events that we want to subscribe to and that movement property we want to pull. And so what we're going to do is we're going to look at our input manager variable and grab the input manager off of it using that helper property that we had added to the base class. That's going to get this interface as a component. So this is just a nice shorthand way throughout this script. I'll just be able to say input manager dot, and that will let us reference our input manager in a shorthand way. Just to make the code easier to read, I want to add a Boolean for whether or not we are the player, because I am using the same script for the player and the enemies, and I could have used polymorphism. I could have had like a common base class and then had separate derived classes and overrode things that were specific to the player or the enemy, but I'm just going to keep it a little bit simpler than that. I think that would be a little bit overkill for something this simple. So I want to have a little bool here to say, am I the player? So I will say bool is player. And again, I'm going to use an expression body method. I'm just going to do a try get component. I want the generic version. I'm going to look for that player input manager. If we're a player, we're going to have player input manager. If we're an enemy, we're going to have an enemy input manager, which doesn't exist yet. So if we successfully get a player input manager component, we are the player. Hopefully that makes sense. I also want to know whether we are a mount, because I'm going to use this same script for the player mount and enemy mount, which is basically the mount where the player's been killed or the enemy's been killed, and the mount runs around until it runs off the board. So we want to know if we're the mount, because there's some special logic we're going to do if we are the mount. And I'm going to split this out over a couple lines because it's basically a logical OR that I'm doing here. I want to see what layer I'm on. I'm going to use the layer mask, name to layer, player mount, or enemy mount. So if we're the player mount or the enemy mount, we're a mount. So hopefully that all makes sense. Let's add another Boolean here called isGrounded. And this is going to be a getter. And I'm making it a full function here, or a full property getter, because it's a little bit longer and bigger than what I want to put in just an expression body method. So I'll say if we're flapping, return false. If we're flapping, we're definitely not grounded because we're intending to lift up off the ground. Otherwise, we're going to do a ray cast. We're going to say physics 2D, ray cast non-alloc. We're going to look at our transform.position, casting down, and we want to use our ray cast distance variable. Actually, we want to look at our ray cast hit first. Then we want to use our ray cast distance and our grounded mask. And what does it not like about this? Yeah, so this function actually returns an integer, which is the number of hits. And so this is a Boolean, so what we want to do is return true if we got more than one hit or more than no hits. Then we definitely hit the ground, so we are grounded. All right, and we're going to actually be allocating that raycast hit array because currently the way we declared it, it's just an empty array. So we're going to have to allocate that before we can actually use it. But we will get to that a little bit later. I want to have another Boolean here, and this will be an expression body method. I'm going to call this input received. And the only time I'm going to use this, I think, is to turn off invulnerability mode, because when the player's spawning in, there's a pretty long period of time where they can be invulnerable. But as soon as they apply any input, if they flap or if they move, they're no longer invulnerable. So I want to know if I've received input. So this, what this little flag is here. Flapping is going to be true if we received input. Otherwise, I want to look at our movement, and I just want to see if it's not approximately 0. So if input manager dot movement dot x is not approximately 0, then we moved. We applied movement input, which is input. So we would have received input. And this is spelled wrong. And it's still spelled wrong because I can't spell. There we go. All right. And I want to have a Boolean to say whether or not we're flying. And that's simply going to be that we're not grounded. I want to rename this to is grounded. All right. So now to get into writing some actual code, I want to have an init method. So when I spawn an enemy or a player, I want to initialize some things for it. Especially for the enemy, I want to initialize their speed factor, and I want to have them have an initial direction as well. So let's add a public void init. It's going to take a vector 3 for its direction, and it's going to take a float for its speed factor. And I'm going to default that to -1. So if I don't pass this in, it's just going to use 1. So the first thing I want to do is set invulnerability to be true. So when I'm first spawning it, I want it to be invulnerable, and I'm going to create that method, which currently doesn't do anything, and I'm just going to call that invulnerable. All right. The other thing I want to do is set its direction to be whatever direction we passed in, and I want to set its speed factor to be the speed factor that we passed in. And I want to show a spawn effect. So I want to have a public coroutine. So I'm going to say public IEnumerator, and I want to use the one from System Collections. So it just added a namespace for me using system.collections. So this is going to take a float, which is how long I want this thing to do this effect. And I actually should name the function, don't you think? Maybe I should call it show spawn effect. All right. And in here, I want to set invulnerable. If I'm displaying the spawn effect, I want them to be invulnerable. So I'm going to set that to true. And this is going to basically take all of the sprites in this guy, or our sprite that we're rendering, and we're going to take his color, and we're just going to randomly change the color. And we're going to do it for that spawn length. And then when it's done, we're going to turn our invulnerability off. So what we want to do is save off our original color. And we're going to get that from our sprite renderer's material. So I'm going to say var original color. Actually, I'm going to say original bird color. And I'm going to say that that equals sprite renderer dot material dot color. And now we want to do some math to determine how long we want to do this loop. So I'm going to have a float called time, and it's going to equal our spawn length. And we're going to say while time is greater than 0 and we haven't received any input. So while not input received, then what we want to do is decrement our time by time.delta time. So time.delta time is the number of seconds that's elapsed since the previous frame. So this is a way to smoothly do things regardless of the actual frame rate of your game. So it makes things frame rate independent. So we're going to take time.delta time, subtract it from our time. And then we're going to set a random color to our sprite renderer. So we're going to say sprite renderer dot material dot color equals random color HSB. That's just going to give us a random color, and we're going to assign it right to our sprite renderer's materials color. And I also want to do something else. I want to actually scale this guy from being very small to being his full size. So let me do that too. I want to initialize our transforms scale to be 0.1. So I will say transform.local scale equals new vector 3, 0.1, 0.1, 0.1. And I should probably make this a float. All right. And so what I want to do in here is if our transforms local scale dot x is less than 1, then I want to do a lerp and lerp it up to its full size over time. So we're going to say transform.local scale equals vector3.lerp. So lerp is a linear interpolation. It's just a way to smoothly apply this transform over time. So we're going to take its current local scale to vector3.1, which is just a constant for 1, 1, 1, which is going to be his full size. And I want to do that lerped over time.delta time. And that needs to be a capital T. All right, so that will do that. And then I want to do a yield return null. So basically this is going to stay in this function, and Unity is going to call this function every frame, and we're going to yield control back so that we don't hang the game engine while we're doing this loop. So we're going to execute a frame and yield control back, execute a frame, yield control back, and so forth. When we're finally out of this loop, when we have either elapsed our time or we've received input, then we're just going to go ahead and set that local scale to 1. We're going to set our color back to its original color. And we're going to set invulnerability to false. So we're no longer invulnerable. So this function here is going to randomize the color of the player or the enemy over a specified length of time. And during that time, we are invulnerable. And what this function is going to do, I haven't written it yet, but what we're going to do is we're going to tell it to ignore collisions. If we're a player, we're going to ignore collisions with enemies. If we're an enemy, we're going to ignore collisions with players. That's all it means to be invulnerable. In fact, let's go ahead and write that function now. So we're going to come in here, and we're going to have our flag. We're going to set it to whatever value was passed in. And while we're invulnerable, we also want to disable our input manager. So we only want the input manager to be enabled if we're not invulnerable. I also want to check to see, are we a mount? Because mounts are going to ignore collisions with players and enemies. Players or enemies are only going to ignore collisions with the other, the opposite. But mounts are invulnerable to everybody. So basically what I'm going to do in here is I'm going to say physics 2D dot ignore layer collision, game object dot layer, and we're going to use a layer mask, name to layer player, true. So we're going to ignore those collisions. I'm going to copy this and paste it, and I'm just going to change this to enemy bird. So that will handle mounts. Otherwise, I'm just going to return. So I could do an else, but if I just return here, I don't have to have a nested else statement in here. So physics.2d, ignore layer collision, game object.layer is player, that's where I wanted that is player flag. So layer mask, name to layer, enemy bird, otherwise, layer mask, name to layer, player. So if I'm a player, I'm going to ignore enemy bird, otherwise I'm going to ignore the player. Okay, that's good. There is our is invulnerable. Let's go down to our awake method. We want to subscribe to the input manager's on flap pressed event. Go ahead and create that function. We'll implement that later. We want to allocate our raycast hit array. So it's going to be a new, and I make it 10. I don't think we're ever going to collide with 10 ground objects. That's overkill, but it's not a problem. We're going to call init and default to vector3.write. And I'm doing this because the initial player doesn't get spawned in. He's already on the map when the game starts. And so I want to, as soon as he awakes, call init, and he will be initialized facing right with a speed factor of 1. And we're going to set invulnerability to be false by default. And the other thing I want to do, if I subscribe to an event, I want to unsubscribe. So I'm going to add an on disable. I'm going to paste in that line and change this plus equal to a minus equal. So we're no longer subscribing to the on flap pressed. Now in the start method, I want to initialize our flap time to be time.time. So we can immediately flap if we want to. All right, let's go ahead and implement an update method. So update is called by the Unity engine every frame. So if your frame rate is 60 frames per second, the Unity engine will call this 60 times a second. And we're going to have two function calls in here. One is going to be handle vertical movement, and the other will be handle, you guessed it, horizontal movement. All right, so let's go ahead and Alt-Enter create function. Delete that. Alt-Enter, try that again. Alt-Enter. All right, so what do we want to do in handle vertical movement? Well, we want to say, are we flapping? Then we want to flap. Oops, I should have hit escape so it didn't auto-complete. I'm going to create that function. We're also going to apply, the very first time we flap, we're going to go ahead and apply some flap velocity in the upward direction. So I'm going to say transform.position plus equals vector3.up times flap velocity times time.delta time. Then I'm going to return. Otherwise, I want to check and see if we're grounded. If we're not grounded. If we're not grounded, then I want to take our animator and I want to set the bool flying to be true. And then I want to apply gravity. So I'm going to have to create that function. Else, and this is a case where I am going to use an else statement, I want to set the animator's is flying flag to false because we are grounded. I want to set our flap velocity to 0. And then down here, I'm going to do another transform position plus equals vector3 dot up times flap velocity times time dot delta time. So when I first flap, I'm going to apply the velocity here and return. Otherwise, I've got flap velocity that I had set. And basically what's going to happen when we apply gravity is we're going to decrement this flap velocity. So we're going to set it to an initial value, but then we're going to decrement it by gravity every frame. And so we want to always be applying whatever our flap velocity is to our vertical position. And that's why we use this vector3.up. So we're applying it in the vertical direction. So we'll thrust up, and then as gravity increases, we're just going to start flapping up less and less and then start falling down. Might as well go ahead and do the apply gravity. So all we're going to do in here, like I said, is say flap velocity minus equals gravity times time dot delta time. All right. And I guess we can go ahead and implement this flap method. So first of all, if we were invulnerable, we want to set invulnerability to false. Just some redundancy there because I should be handling that in that display spawn effect. All right, so our flap time, we want to reset it to be time.time plus our flap delay. So no spamming of the flap key. We're going to take our animator and we're going to set the bool for flying to be true. If we hit flap, we want to tell the animator we're flying. We also want to trigger the flapping trigger. So that will trigger the flapping animation, which will also play the flap sound effect. We want to set our flap velocity to be flap force. And then that will gradually get degraded by gravity. We want to set our flapping flag to false. So we only want to do this once. So when we receive that flap input, we're actually going to set that flapping to be true. So if we're flapping, when we're in the update method, we handle vertical movement, then what we want to do is only do this once. So we're going to set this to false. Also, we want to set skidding to false. If we're flapping, we're not skidding. Okay. So let's handle horizontal movement. First thing I want to do in here is say, should we skid? And if we should, then I want to start skid. So, of course, neither one of these exist. Let me move this up above here. And what do we want to do in should skid? Well, it's going to be a getter. And what we want to do in here is say, if we're skidding or we're flying, then return false. So if we're already skidding or if we're flying, we don't want to start skidding. I also want to check our move velocity. And I only want to skid if we're moving fast. So if our move velocity is less than 0.75, I'm going to return false. And then based on our direction, whether or not we're skidding is going to depend on whether we're going the other way or not. So I'm going to say if direction is vector3.right and input manager dot movement dot x is less than or equal to 0f, return true. Otherwise, we're just going to return direction is equal to left, and our input manager dot movement dot x is greater than or equal to 0. So basically, if we're moving right and we either stop moving or we move to the left, we want to skid. If we're moving left and we either stop moving or move to the right, we want to skid. So that should skid. All right, and you know, this does not need to be public, so I will remove that public keyword. All right, I want to say skidding equals true. So remember, should skid is going to check to see if we're already skidding. So we want to set that flag because we don't want to initiate skidding if we're already skidding. I want to set the float on our animator for speed to be 0. I want to trigger or set the Boolean for skidding to be true. And I want to set our current skid time to be 0. All right. So back up to handle horizontal movement. If we're skidding, handle skid movement. And return. So what do we do in handle skid movement? So the first thing we want to do is take our transform position and we want to add to it our direction times our move velocity times time.delta time. So we're still moving in whatever direction we were moving, so we want to apply that movement. And then we want to take our move velocity and we want to make sure that it's no greater than, or we want to make sure it's at least, excuse me, because we're going to be decrementing from it, but we want to make sure it doesn't go below 0. So we want to say move velocity minus move speed times 0.1f times time.delta time, or 0. So mathf.max says, I'm giving you two values. One is going to be this equation, and the other is going to be 0, and I want to take whatever's greater, and I'm going to assign it to this variable. So our equation is take our current move speed and subtract, this should be, I'm going to put this in parentheses just for clarity, and Ryder is even going to tell me I don't need the parentheses. You see how they're gray? But just for clarity, so basically I'm going to take move speed times 0.1f times time.delta time, and I'm going to subtract that from our current move speed. So we're going to gradually be slowing down while we're skidding to a halt. And this is just an arbitrary value that I came around with playing around with it. We're going to assign that back to here, and we're going to make sure we don't go below 0. Then we're going to add to our skid time. Current skid time, we're going to add to it time.delta time. And if our current skid time is greater than or equal to skid time, this is basically how long the skid effect should last, then we're going to call stop skid. And in stop skid, I'm going to say that move velocity is going to be 0. So we've come to a halt. We're no longer skidding, just to make sure. And we're going to take our animator and set the bool for skidding to be false. So we're going to switch off of that skidding frame that we've been sitting on. So we should now have flapping working. We should have skidding working, but we still have not implemented the basic horizontal movement. The next thing I want to do in here, though, is see if we should change direction. So by the way, I'm going to turn on GitHub Copilot because when I was first writing my little prototype, it was amazing that it knew what I wanted to do when I said if should change direction. So if should change direction, change direction. And again, I should have hit escape so it didn't auto-complete. So let me take this and hit Alt-Enter, create property, should change direction. And I'm surprised it's not suggesting anything here. But let me just get rid of this, give it an open and close bracket, and say if direction equals vector3 dot right, and input manager dot movement dot x is less than or equal to 0f, return true. So this is basically like the skidding logic. If we're moving right and then we start moving left, so less than 0, we want to change direction. All right. Otherwise, I want to set our move velocity to be 0. And I want to return direction. I'm not sure why I have this line here. I'm going to comment this out and see what happens. That seems weird to me. So otherwise, if we're moving left and then we move, our movement control says move right, we want to switch direction. So let's go ahead and implement change direction. So I'm going to go there, hit Alt Enter, create method. Delete that. I'm going to move this down below should change direction. And in change direction, let's see if that's right. It's saying if we're moving right, then we want to switch to left. Otherwise, we're going to switch to right. So that is correct. The other thing I want to do is I want to actually rotate our game object. So I'm going to say transform.local Euler angles. And that is not what I want. Well, it's not how I would have written it, but it looks like it would work. So let me look at this. We're going to basically change our Y axis to 180 if we're 0, or to 0 if we're 180. I think that's right. We'll give it a test and see if it works, but that's not how I would have written it, but that's what GitHub Copilot suggested, and I'm going to give it a try. And again, this does not need to be public. Okay, so we have our change direction logic. Now I want to say if we're invulnerable, and I'm going to use this approximately helper again, input manager dot movement dot x. I'm comparing it to 0. So if we're invulnerable and we moved, set invulnerability to false. So this is redundancy again. We should already be handling this in that show spawn effect, but just in case we're invulnerable and we're outside of that function, I want to, whenever we receive movement input, I want to make sure we're no longer invulnerable. So it's just redundancy. Now we're going to actually apply our movement. So I don't know what GitHub is suggesting there. I'm not going to use that. I'm going to say move velocity equals mathf.absolute. So whether we're moving left or right, I don't care. I want to use the absolute value. So if it's negative, it's going to become positive. We're going to take our x movement, and then we're going to multiply that times our move speed times our speed factor. All right, so that's our move velocity. And now let's go ahead and apply that move velocity whatever direction we're facing times move velocity times time, that delta time. All right. And the other thing I want to do is I want to set the speed property on our animator so that we switch to that running animation. So animator.setFloat speed mathf.absolute, not approximately, absolute, input manager.movement.x. And what does it not like about that? Oh, I just needed to get off the line. All right, so that should be our vertical movement and our horizontal movement. I'm going to zoom out just a little bit, get a better view of the whole file here. This is not all the logic that we're going to have in this file, but Actually, it might be. We never handled on flap press. So let's go ahead and do that. And on flap press, we want to say if can flap, then we want to set flapping to true. All right, let's jump out into Unity. Let Unity recompile all that. And I'm just going to make this game view bigger. And this is going to be our first real test. I will be amazed if it works the first time. Hit play. Well, he's standing. He's running. He's falling. He's running. Oh, I'm not handling. I need to add a teleporter script. So if he goes off this side, he comes back in this side. But let's go ahead and hit play again. I'm going to try flapping now and see what that does. I don't know about you, but I'm pretty happy with that. That looks pretty good to me. So let's go ahead and add that teleporter script. I'm going to collapse this. I'm going to right click in here under our scripts folder, create C# script, teleporter. And let's go back over to our player, let Unity recompile. Double click to open that up in the editor, zoom in, delete the boilerplate, get rid of these unreferenced using statements, add a serialized field, and this is going to be our boundary. I'm going to guess around 6.6F. Let me go ahead and turn off GitHub Copilot again. If mathf.absolute transform position.x is greater than boundary, then teleport. Yep. And I like things to be explicit, so I'm going to take this, right click, refactor, extract method, should teleport. So if should teleport, then teleport. And I'm going to make this an expression body method. And that doesn't need to be a function. There we go. All right, so in here, teleport is going to be simple. We're going to take our current position being our transform position. We're going to take the x and multiply it by -1. We're going to assign it back to our position. And then we're going to make sure our Euler angles are pointing the right direction based on what direction we should be facing. So depending on where we are, if it's greater than 0, then we want to be facing left. Otherwise, we want to be facing right. And this is basically yelling at me saying that we're inefficiently accessing this property multiple times. I'm not going to do anything about it. It's not going to make a difference. We're only teleporting this one instance. It's not going to be a performance problem at all. Okay, so let's go back and test that functionality. We've got that script here. And I just want to make sure that 6.6 makes sense. So I'm going to take our player. We're looking at him in our scene view here. We're going to expand this transform, look at his position. I'm just going to take him and grab him. -6.6. He's about halfway across. So yeah, I think that makes sense. If he gets to 6.6, he'll come back out the other side. And I'm going to go ahead and set his start position to be but roughly where he's supposed to be at the beginning of a level. And I'm going to hit play. And we're going to give this a test. Oh, I did not put a collider on the ledge. He fell through the ledge. All right, so let me do that real quick. We will go to our background, ledges, left ledge. Look at that in the scene view. Add component, box collider 2D. Let's look at that collider. I'm actually going to make that thing extend beyond the edge quite a bit. In fact, I'm not going to do that. I'm going to actually size the whole ledge. Let's see, ledge, left ledge. I want that to extend well beyond the edge. Let's look at his box collider. That looks good. Let's go to the other one. I'm going to extend him beyond the edge quite a bit. Add a box collider. Okay, that looks good. Let's give that another test. Okay, I'm liking that. In video game terms, we call that an expanded universe. Okay, I'm going to go ahead and apply these changes to the prefab, and we're going to create another script on here. We're going to add one called Thunk. So create C# script, Thunk. All right, let Unity recompile again. Drag that on there, open it up in the editor, zoom in, get rid of the boilerplate. And I want to have a public event on Thunk and initialize it to a delegate. Actually, let me go ahead and add this system.action namespace, get rid of the unused directives, and assign that to an empty delegate. So we're going to handle on collision enter 2D, and I'm going to rename this guy to other because we're colliding with something else. And I say if other dot collider dot game object dot layer is not equal to layer mask dot name to layer ground, then just return. I shouldn't get any collision events for anything other than that because, well, actually it's not true. Yeah, because I do collide with other things. So I want to make sure this is a case where I can't just use the physics collision matrix. I actually have to check to see what I'm colliding with in code. So if I'm not colliding with the ground, I don't care about thunking. Let's also look at the contacts that we're colliding with. I'm going to use a link expression here. I can't type contact.normal.y. So basically, if I'm not, I want to do a not here. If I'm not hitting something, if it's not hitting me from above or like from the upper right half of my object, then I don't want to do this thunk nonsense. So return and do nothing. Otherwise, I want to play the thunk sound, or the thud sound, I guess it is. And then I want to fire that on thunk event. Now, the player is not going to do anything with that event, but the enemy is. The enemy's going to like change direction, get knocked back, and start going the other way. The enemy input movement controller is what's going to handle that on thunk event, and that's going to be used by the mounts and the enemy. So yeah, let me get rid of this unused using statement. And if we give this a test, what should happen is when I fly into these platforms, it should play that thunk sound. Go ahead and hit play. Yep. But if I land on top, we don't get it. It's only if I hit it from the bottom. Nice. So it's time to work on our enemy. I'm going to go into our prefabs folder, take our player, select it, and hit Control D to duplicate, and I'm going to rename this guy to enemy. And the enemy is not going to have a player input manager, so I'm going to remove that. Let me double click the enemy prefab. So I got him here. I want to change his layer to be enemy bird and apply that to all children. Obviously, these sprites are not right, so we're going to pick our sprites and animation, open that up, and we're going to use the green bird And I think I want to use this one here. Well, this one looks good. And for the knight, we want to use the red knight. There we go. Nice enemy sprite. So we're going to work on his animations now. So what we'll do is we'll take these player animations. I'm going to hit Control A, right click. Actually, I can't do it there. I got to say Edit, Copy, or I could have just said Control C. I'm going to go into the enemy animations and hit Control V. And I'm going to rename this to Enemy Animation Controller. All right. So this guy here, his animator, is currently using the player animation controller. We're going to replace that with the enemy animation controller. And right now, all the animations are still using the player sprite for the bird. But we are going to change that, and it's very easy to do that. What I'm going to do is for each animation, I'm just going to go into the art folder and drag the appropriate sprite into these frames. So with sprites and animations selected, I'll pick the first one, which is falling. We'll go into our art folder and we'll scroll down until we find the green bird with the wings up, which is this one right here. I'm just going to drag that right there. All right, Control S to save. I'll now switch to flapping, and we're going to drag that there, and we're going to drag that there. So if I hit play, you can see it's got the right sprites. Let's switch down to running, and let's see, we're going right. So I want to take this one, that one, that one, and that one. Nice. Okay, and then skidding, it's going to be that one. Standing is going to be this, I think this one. Yeah, I think that's right. All right, so now we should have an enemy with the correct sprites and the correct animations. And we may have to go in and edit his colliders and stuff at some point. Yeah, that definitely looks wrong. Actually, let me temporarily change this sprite to be a flying one. Okay, and then the knight looks fine. Change this back. Okay, so hopefully now we have a well-defined enemy. The next thing we want to do is actually work on the AI input manager for the enemy that's going to control his flapping and moving and all that good stuff. Now for some really fun stuff. We're going to implement the AI for our enemy movement. So we got our enemy here. Let's go into scripts, input, and I like to be able to see the full names. And we're going to create a new script here and call it Enemy Input Manager. So create C# script, Enemy Input Manager. Again, let Unity think about it. Select our enemy and drag Enemy Input Manager onto there. And double click to open it up in the editor. Zoom in. Get rid of the boilerplate. Oops. Okay. So this is going to be a fun script. At the top here, I want to have a public vector for our movement. And remember, this is going to be, actually before I do this, we do not want to inherit from mono behavior. We want to inherit from input manager base, and we want to implement the input manager interface. So select that, implement missing members. It's going to give us a movement, on move received, on flap pressed. And there we go. What I want to do here is add a private setter. And of course, these guys I love to initialize with an empty delegate. like so. All right, scrolling down, add our serialized field. So for the first thing we want is we want to have a interval range for how often it will flap. In this value, this is where we can really do some tuning, because if he flaps too often, he's just going to stay up at the top of the screen. But if he doesn't flap enough, he's just going to fall down to the bottom. So we have to really come up with a healthy balance here. And I am going to go with a value of 0.5 and 3 for our initial values. We're also going to want to have a direction change interval. So he will periodically change directions. And that's also going to be a vector 2. And I'm using a vector 2 because it's just a min-max, right? So the same here. This is like the minimum interval, and this is the maximum interval. Minimum, max. And a float for its max height. We don't want them to flap up off the screen. And I want to have a kickback boundary. If I apply kickback and he's too close to the edge, I had some problems in testing where he would get knocked off the edge of the screen and not teleport correctly. It was weird behavior. I only want to apply kickback if he's within a certain section of the screen. Okay, so now we want to do float next flap time. I want to have a vector 2 for our direction. And so a lot of this is going to be very similar to the players. So we want our next direction change, Thunk. And then I want a couple of read-only vector 2s for move left. This is basically what we're going to apply to our position if we're moving left. Move right. Alrighty. So in onEnable, when this script is enabled, we want to set our next direction change time. And we want to subscribe to the Thunk event. And we want to set our initial direction based on our current facing of our object. So if we're facing right, our direction is vector2.right. Otherwise, it's vector2.left. Okay, let me go ahead and create that method. Create that method. Also, when we subscribe to events, we want to unsubscribe. So on disable, unsubscribe from Thunk event. And let me just move this down. And let me move this up. Okay. We'll get to implementing them later. Update. And update. If we should flap, then flap. And again, I should have hit escape so it didn't autocomplete. Create that function. And create that property. Oops. Okay. The other thing we want to do in update is if should change direction, And finally, the last thing we want to do in here is move. So go ahead and create that. And create that. All right, so let's go down and look at all these things here. One thing we want to do is set our next direction time. So our next flap time is going to be a random range. Now I wonder what it did for random. Okay, it did not do what we wanted to do. It used system.random. So let's go down here and use Unity engine.random. Okay, so we want to use our flap interval range.x, our flap interval range.y, and we want to add to it time.time. That's going to be our next flap time. Nice and simple. Subscribe to Thunk event. Basically, I want to do a try get component of type Thunk, out Thunk. If Thunk, I love that name, Thunk.onThunk plus equals on Thunk plus equals. And I will Alt-Enter to create that. Okay, now to unsubscribe, it's going to be very simple. I'm just going to say if Thunk, I'm going to copy this. There we go. Change that to minus equal. All right, I'm going to move both of these down to the bottom of the file. They can be the last thing in there. That's fine. All right. Move. What are we going to do in move? First of all, we want to set movement to be our move direction. And then we want to fire the onMoveReceived event, passing in movement. So you see, it's very much like the player input controller or player input manager. We're setting that move property and we're firing the move event. So the bird mover script doesn't care where this is coming from, whether it's a player moving the stick or whether it's our script doing this. It's going to respond accordingly. So get move direction, we're going to return direction equals either vector2.right or move right or move left. So if our direction is right, we're going to pass back move right, otherwise move left. All right. How about should change direction? I want to make should change direction an expression body method up at the top of the screen. So I'm going to delete this and move it up above our functions. And it's basically going to be an expression body method that says time.time is greater than or equal to our next direction change. And I'm going to go ahead while I'm up here and add a should flap. And that will be transform.position.y is less than max height. And time.time is greater than or equal to next flap time. Now it's complaining because there's already a should flap down here somewhere, which I'm going to delete. All right, so we've got those flags now. So let's go down to the change direction function. I'm going to say set next direction change time. And then I'm going to say direction equals, and basically going to say if our current direction is vector2.right, then we're going to switch it to vector2.left. Otherwise, switch it to vector2.right. So that's simple enough. How about flap? What do we want to do in the flap function? First thing we're going to do is set our next flap time, just like set next move time. And we're going to fire the onFlap pressed event. Okay, so set next flap time. Next flap time equals random.range flap interval range.x flap interval range.y plus time.time. So we're going to be some random range between x and y, add it to time, nice and simple. What do we want to do in onThunk? Well, if we thunk, we want to change direction. And we want to apply knockback. So apply knockback. Take our current position. And check. Oops. If mathf dot absolute position dot x, if that is greater than the kickback boundary we've set, then return. All right, so if our position is greater than the kickback boundary, either negative or positive, we want to return. Otherwise, we're going to take our current position and we're going to add the move direction times half a unit. So we're just going to knock ourselves back half a unit. And then we're going to say our transform position equals position. Sign it back. Autocomplete, you're killing me. Okay, so I think that is good. Is that everything that we need? I think that might be everything we need for this function. So to test this out, let's go back out into the Unity editor. We're going to have to add that script. All those things look like they are there. So our bird mover needs that input manager. All right, so let's add an enemy to the scene and see what happens. Go to our prefabs, drag an enemy in here, and hit play. So he's flipping around directions way too much. I'm not hearing the flap sounds. He's not switching to the run animation. So there's some things that aren't quite working right. But he is moving around. He's not flapping. So definitely some things to debug there. So one thing I notice is I don't need this player input component. So I'll remove that and I will apply that. I think I want this ray cast distance to be a little bit smaller for the enemy. And I'm going to set the skid time to 1. I don't think that should make a difference. Let me just hit play again and see what happens. Yeah, again, that changing direction stuff is not working. He's also definitely not colliding with the player. Let me go look at our physics. So enemy bird should collide with the player. I wonder if the invulnerability is on. Let me hit play and look at this screen. Yep. Invulnerability must be on because it turned that off. So we'll fix that. But it's interesting that they're so far above the ground. So I think we're going to need to play. I'm going to hit the pause key here. And that raycast distance is set to 0.52 again. Okay, that's too low. I think that looks about right. Maybe 0.4. So stop playing, set that to 0.4. So to debug that stuff, let's go back into our enemy input manager. And I see right here something. We're not actually referencing our direction change interval. That should be done in should change direction. So let's scroll down and look at that. Oh, well, look at this. We're using our flap. So let's set next direction change. And we want the direction change interval range. Jump back out into Unity. Hit play and give that another test. All right, so we've got him flying around. He's thunking, he's teleporting, and it seems to be reasonable balance between flying and falling. All right, so far so good. Well, the whole point of Joust is jousting, and now that we have an enemy, we can actually work on implementing, resolving our joust when we collide with them. So let's go back to our player first and go down into scripts here. We don't want this to be under input. I think I'm going to put this up in the parent folder here, and I'm going to call this Joust Resolver. And once again, let Unity think about that. Select our player. And I'm going to drag that guy on there. I'll select our enemy and drag that guy on there. And just so I don't forget, apply prefab. And while I'm here, go ahead and save the scene and save the project, just in case Unity crashes. Let's open up our Joust Resolver in the Unity editor. Zoom in, get rid of our boilerplate. And what do we want to do in Joust Resolver? Let's see, we want some serialized fields, of course. For one thing, if we lose a joust, we're going to spawn our mount. So we're going to have to actually create a mount. But for now, let's just put a game object there for our mount prefab. The other thing we're going to want to do is lay an egg. If we're an enemy, that is, we're going to lay an egg. So obviously egg doesn't exist. So let me come down here and say public class egg mono behavior. And then we will alt enter move. I want to do it from egg. Move to egg.cs. And I only did that to get rid of that error. All right, we want to have a flag to say whether or not we're dead. And we're going to handle on collision, enter 2D. And I'm going to rename this to other like I usually do. And the first thing I'll do is say, am I dead? If I'm dead, just return. Okay, now we want to see, is the thing we collided with something that we can joust with? And the way that we check that is to see if they have the Joust Resolver component. So I'm going to say var opponent equals other.collider.gameObject.get component. And we actually want to look in the parent, because we're colliding with this collider, and if you remember, the colliders are down on those child objects, the flying bird, standing bird, and knight. So even though we're registering the collision up at the rigid body layer level, this is actually happening down in a child level, so we need to look in the parents to see if it's got this component. And what we're looking for is the Joust Resolver. So if we have one, or if we don't have one, we're just going to return. Now we want to say, did we lose the joust? If not lost joust, passing in our opponent, again, just return. Alt enter, create method. Otherwise, we're going to set dead to true. We're going to spawn a mount. And then, basically, if it wasn't an enemy that lost, then we're going to score points for this. So we currently don't have a score manager. So there's so much to do here. Right now I'm just going to return false. Get rid of that error. Let me go ahead and create that. Let me go ahead and create that. We need a score manager, but I'm just going to put a comment here and say to do score points for killing enemy. And now because this is a to do, if I come down here and look at to do, there's one in my project, which is score points for killing enemy. It's a way to keep track of things that you plan to implement later. So let's see, we'll say if not try get component enemy input manager out var enemy input manager return false. So at the thing that the thing that lost the joust, the thing that we beat in the joust is not an enemy, then we're going to return false for this removed enemy. So I know this is getting a little bit confusing. There's stuff that we have not done yet. We're eventually going to have an enemy manager that we're going to call, and it's going to remove this enemy from the list of enemies. And that's how we know whether or not we've completed a level or not, if we've killed all the enemies. But for now, one thing we want to do is spawn an egg. The other thing, let's put a to-do in here. Hey, look, there's another to-do down there. And we want to disable our input manager because they're dead. And then remove enemy from enemy manager and return true. All right, so there's the main thing for remove enemy. What are we going to do in spawn mount? Well, we're going to if mount prefab instantiate the mount prefab at our position using our rotation. So essentially, a bird without a rider is going to appear at the same spot facing the same direction as us. Okay, so how do we know if we lost the joust? Right now I'm just returning false, so that's not good. We don't want to always lose, do we? How do we handle lost joust? So what we're going to do is we're going to say opponent's position dot y minus our position dot y is greater than a quarter of our height. So basically, if he hit us higher than we hit him, we lost the joust. Very, very simple. And I think that's pretty much, I guess we could do the egg, spawn egg, even though we don't have an egg prefab. But let me just see how I would do that here. I would say if not egg prefab, return. That way we won't get an error for not having it. Otherwise, we're going to instantiate the egg prefab at our position. We'll use quaternion identity for the rotation because it's just a sphere basically. And then we're going to check to see if it has a rigid body. So if not egg prefab dot try get component rigid body 2D, and I want the generic out var rb return. And actually what I want to do here is I want to say var egg, and I want to use the egg. And then I want to apply some force to the egg. And we're going to calculate a direction for that. And it will be transform.Euler angles equals vector 3.0 means we're facing right. And if that's the case, then we're going to use vector 3.right, otherwise vector 3.left for our force direction. And then we'll say rb.add force force direction times, I don't really know how much force I want to add. Let's try something like 5F. And we want to use impulse. All right. Now, none of that's going to happen anyway because we don't have an egg prefab, but at least that is all coded. All right. I think that's all we need for our Joust resolver. What we're going to want to do, though, is we're going to actually want to create a mount now, both for the player and for the enemy, that we can put into that mount prefab. And we're going to want to create the egg so we can get all that working. So let's go out into Unity. And so you see we need a prefab for these guys. So let's do the player mount first. Let's go into our prefabs folder. Actually, did we apply all our overrides? Yeah. Okay, so using our player, I'm going to duplicate, and I'm going to rename that to player mount. And we want to open that guy up and set his layer to be player mount and all his children. He will not have a knight, so I can just delete that, and that goes away. We are not going to have a player input manager or a player input. We are going to have a bird manager, and we're actually going to add the enemy input manager. Right? And let's go ahead and drag that up here. We're going to want to add a script to this guy to despawn the mount when he goes out off the board. So let me do that real quick. I'll go into scripts, create C# script, and I'm going to call that mount despawner. And we'll put that up here. Double click that to open it up in the editor. Zoom in. Get rid of the boilerplate. And we're going to add a serialized field, basically where we want him to despawn at. So we'll call it boundary. I like that word. We'll say 7. I know that's definitely off the screen. In the update method, we'll just say if mathf.absolute transform position.y is greater than or equal to boundary, despawn mount. All right. And now, if we are the player, then we're going to want to tell the game manager that the player despawned. Because the way this is going to work is when the player dies, his mount's going to fly off the board. We don't want to spawn a new player until the mount flies off the board. And so we're going to actually tell our game manager, hey, the player mount just despawned. You can spawn another player. So what we'll do is we'll say if the game object dot layer is equal to layer mask named layer player mount. If that's the case, then we want to find object of type game manager. And if we got it, we want to say player mount despawned. And I'm going to go ahead and create that function in the game manager, and it's not going to do anything yet. Then we're going to destroy this game object. So right now all we care about is we want this guy to die when he goes off the board. All right. Let's go back out into the Unity editor, and in our Joust resolver, we want to go into our prefab folder, and we want to drag in the mount prefab. And why does it not like that? Oh, I know. I think I know why. No, I don't know why. It should accept any game object. Oh, this is the player mount. The player mount should not have a Joust resolver. Okay, all that looks good. Let me go pick the player. Joust resolver. Why is that a game manager? Oh, there's our problem. This should be game object. Autocomplete. Now it'll work. So, prefabs, player mount. There we go. Okay, now we want to do the same thing for the enemy. So let's take the enemy here, duplicate it, rename this to enemy mount. All right, double click that, set its layer to be enemy mount, all his children. He does not want a Joust resolver. I think all of that looks good. Doesn't need a knight. Get rid of that. Okay, so now if we go to the enemy, his Joust resolver can take an enemy mount prefab. All right, now we want to create an egg. So let's just create a new object for the egg. So let me just collapse some of these things. And once again, I want to make sure I override my prefabs. Okay, so I was actually working against the prefab, so I'm good there. So right click here, create empty egg. I'm going to add a rigid body 2D. Okay, and I think this guy, he is going to really react with physics, so he'll have gravity and everything like that, so that's fine. I'm going to add the egg script. And we can edit that. But first I want to add a sprite to this guy. I'm going to do the same thing I did before. Say 2D object, sprite, circle. But then I'm going to actually replace that. Where is the egg sprite? Here we go. And that's awfully darn small. So go up to your scale. Let's scale that up a little bit. That looks more like an egg. All right. I'm going to give it a circle collider. I'm going to rename this. And I'm going to do the same thing I did before. Sprites and animation. Because there will be an animation for this when it hatches. Let's add a circle collider 2D. And I think that's good. We're going to add an animator to it eventually and a hatch script eventually, but for now, let's just leave it like this. Go into our prefabs and drag that like so. So we'll get this hatching later, but for now, delete that from here. We'll go into our enemy and into our, actually I want to go into our enemy mount. No, the Joust resolver. So we want to go into our enemy Joust resolver. We want to drag in that egg prefab right there. The player will not have one because he does not lay an egg. All right, let's see what happens if we try to joust. We're not colliding. For some reason, one or both of us are still invulnerable. The player is ignoring enemy bird. The enemy bird is ignoring player. So that definitely needs to be addressed. Let's stop playing. Take our player first and go into the bird mover script. And let's just look at our invulnerability logic and see what I can figure out here. So we're not even doing the show spawn effect, so that's irrelevant. Here is our set invulnerability. We pass in a bool. All right. This we can ignore because we're not a mount. Although I'm going to put some debug logging in here, just so I can put some stuff in the console. Mount is invulnerable. And I'm going to actually give it a name. Mount name is invulnerable. This is a way with this $sign in front of the string. I'm doing string interpolation, and I can actually include variables inside the string just using these curly braces. And so it's going to display the value of name, which is a property on the game object. The other thing I want to do, I think I see the problem. I left off a parameter. So this ignore layer collision, there's an override for this that takes a Boolean, and I think if you don't specify that Boolean, it defaults to true. All right, I think that's going to fix our problem. Let's go back out into the Unity editor. Chase him. Come on, change direction. Here we go. Well, it did not quite work, did it? That is interesting. Okay, so let's take a look at what happened there. If we go into our Joust resolver, and if we lost Joust, return, so if we didn't lose Joust, return. So the enemy lost the Joust, and so he went down to spawn mount, and I'm pretty sure that worked. We saw a mount spawn. And then we call this removed enemy. I think I saw it spawn an egg. I don't think it disabled the input manager. Well, we never do remove the enemy, though. So I think we need to implement that. For this to work correctly, we need to actually see the enemy go away. So for now, temporarily, I'm just going to say destroy game object and see what that does. Well, that works. He's never despawning, but... Oh, because he's got the teleporter on him. Okay, so there's two ways to play this, right? In the real game, that mount doesn't despawn, because what happens is these eggs can hatch into enemy knights, and then those birds can come back and pick up those eggs. So I can either get rid of the mount despawner that I put on them, or I can get rid of this teleporter from the mount. For now, to keep it simple, I'm going to remove the teleporter. And definitely want to remove it from the player mount. And maybe if there's enough interest, I'll do a part 2 of this video and I'll implement the extra features where they can go pick up the eggs after they hatch. Right now, the player can go pick up the enemy knight after it hatches and get points for it, but the enemy mounts just go off the board and disappear. Okay, there's a couple other things I noticed. I noticed that the egg seemed to have way too much force applied to it. So I want to change that. And the other thing I noticed was that the egg actually fell through the ground on the ledge when it was rolling on the ledge. So it just went right down here. So what I want to do is check the eggs, and it's not on the egg layer. So let's go ahead and make that the egg layer. Yes, for its children as well. All right. So that should handle that. I'm pretty sure if we look at the physics settings, that the egg collides with the ground and the player. Okay, so that's all very good. Eventually, the player, I'm going to have an egg collector script on the player to pick them up and score points, show some text that will go up and fade out that shows how many points you got for collecting the egg. But for now, I think the next logical step would be to actually work on our enemy manager that's going to spawn enemies to fight instead of them just having this one enemy here to make this more of a playable game. So in order to spawn enemies, we need a place to spawn them at. Let me go ahead and delete that. We go to our background, and under our platforms, we're going to want to create some spawners. So if we look at this platform, and this platform, and this platform, there are basically 4 spawners that we can have. So I have in my art folder, let me collapse this, an image here for spawner. So what I'm going to want to do is create a spawner prefab that I can drop onto those individual platforms for where we want to have a spawner. So what I'll do is in platform middle high, so if we look at it in the scene view, that one has a spawner. I'm going to right click, create empty, and I'm going to call that spawner. And I'm going to add a sprite renderer. And I'm going to expand that and drag that spawner sprite right over there. And I'm going to want its order and layer to be 2. So it's out in front. And you can tell it's a little bit too small. So let's scale this guy up to something like that. And if you're wondering, why am I adding another sprite when it's already showing a spawner there? It's because we're going to apply that spawn effect to this. So it's going to have that kind of scintillating effect while something is spawning on it. We're basically going to do that by randomly changing the color the same way we did to the player when the player was spawning. And we're going to create a script called spawner. So right click, create C# script. Spawner. Let Unity think about that. And I will drag that script over there. And I think I will make a prefab from this just so I can easily copy it to the other platforms. So let's edit that script. We will zoom in, get rid of the boilerplate. And let's see, we're going to have some serialized fields. We want to have a bird mover for our player prefab and our enemy prefab. So the same spawner can spawn either enemies or players. And then serialized field audio clip for spawn player sound and spawn enemy sound. And then a sprite renderer that we're going to use to do that scintillating random color. And we could get that from a serialized field, or we could get that with get component. Let's just use a serialized field. And to test this, by the way, I can add a context menu. So this is kind of cool. So it's a public void spawn player. And I'm going to add an attribute to it called context menu spawn player. So we're going to have the sound manager play audio clip. We want it to play the spawn player sound. And we want to instantiate a player using the player prefab at the spawner's transform position using quaternion identity. We're going to initialize that player, and we're going to randomly choose whether he's going to be facing left or right. So I'm going to say random.range, and of course we don't want system.random. Random.range. Let's see, we want from 0 to 100. If it's greater than 50, then we want it to be vector 3 dot right. Otherwise, vector 3 dot left. So it's smart enough to know what random range to use. Okay. Let's see. I want to set the local scale 0.1f. And I want to start a coroutine using the player's show spawn effect. And we're going to use the length of the spawn player sounds audio clip as the duration of that effect. And then we're going to start another coroutine. This one's going to be in our class. Coroutine. Show spawn effect. And again, spawn player sound dot length. So down here, we're going to create an IEnumerator show spawn effect float spawn length. And this will be system collections. All right. So in here, we will say float time equals spawn length, while time is greater than or equal to 0, time minus equals time dot delta time. And now we're going to take our renderers, material, color, and set it to a random. Why does it keep doing that? Random escape color HSV. Yield, return null. Then we'll set our renderer back to white, because I know that the full color is normally just white. All right, that will do the scintillating effect on the spawner itself. Now we want to duplicate this, but we want to do it for our enemies. So we'll say spawn enemy, spawn enemy. We will say spawn enemy sound. We want to use the enemy prefab. So even though we're calling this player, I'm going to rename this. I'm going to call it enemy. There we go. All right, so now we have a spawner. We just got to assign these different variables in the inspector. So let's go back out to Unity. And we got these guys here. So let's go into our prefabs. We want enemy here. We want player here. And then our renderer is going to be from here. And now in our sounds, our audio, player spawn, enemy spawn. All right, so let's see if we can't spawn an enemy. I am going to right click on there and say, where's that context menu at? Oh, okay. Spawn enemy. That looked pretty good. Let's try and spawn player. Oh, that looks like an enemy, doesn't it? Really bizarre. Did I draw the wrong? That's really strange. So let's look at this guy here. Let's go look at our player prefab. That definitely doesn't look like the enemy. Okay, so I hate that I have to do this, but let's go ahead and do it. Let's go into our prefabs, enemy, actually animations, enemy animation controller, all right? And I just want to make sure I'm on the right guy here. Yep. And if I pick this animation, you see it's in the player animation folder, which is all wrong. So let me come in here, delete all these. Yep. And take all these and move them into there. Right? So now if I come into here and click that, it's referencing them from the enemy folder, which is correct. And so they're all referencing the correct sprites for the enemy. So now I'm going to copy these. I'm going to paste them in here. I'm going to open up this animation controller. I'm going to go out to our player, see prefabs, player. Just make sure I'm showing that. And I'm going to delete all of these guys. And we're going to start adding these. So first let's add standing. And that will be our default. Okay. And then we're going to add running. I'm trying to remember how I had these laid out. So standing, running, falling, flapping, skidding. All right. So standing to running. And that will be, and I'm actually going to just stop the video and I'm going to do this off screen. You've already watched me do this once. If you want to rewind back to that part of the video, you can follow this, but I'm just going to go ahead and do this and then resume after I've got it all done. Okay, so I've gone in and I've cleaned up all of these guys. Basically, I had to replace all the sprites to be the blue sprite for the bird, like I did before. The other thing I had to do was, if you actually select the animation and look at it, I had to turn off loop time for falling, skidding, and standing. So now if I hit play, and I'll just move around so you can see the player looks good now. Okay, so I think I've got that worked out. Let's right click on our spawner here and spawn an enemy. And that looks good. Now let's try and spawn a player. Okay, and there we have the player. Cool. So the reason I was only controlling one player at a time is there can only be one active player input component at a time. So anyway, that worked. We have a single spawner, and I am going to go ahead and drag that into these other guys. And we can test them individually, but then we're going to go work on the enemy manager, which will spawn all of the enemies that we need for the level. Okay, and so we're back. I have added these 4 spawners. I actually moved this platform down to the bottom, so it would be the last spawner in the list. And we hit play. By the way, I also adjusted my box collider on this platform. It was a little bit too high, and when the enemy spawned, he just fell out the bottom. So I've fixed that. But I'll give it a quick test. We'll start with this bottom one. And I'm going to disable my player. I just don't want him to get in fights with the enemy. So I'm going to come over here to player, just disable that. All right, so now if I right click on this spawner and say spawn enemy. Yeah, you see we got an enemy. Let's try the other one here. Spawn enemy. We got one up here. Right click spawn player. That looks like a player. Let's try spawn enemy. Okay, there we go. All right, so it looks like these guys are all working. Yep. Okay, so we've got our 4 spawners. The next step is definitely to do the enemy manager and have it spawn our enemies. So let's collapse our background here and go into the managers. And we're going to right click, create empty. enemy manager, and I'm just going to move it up above the game manager. And then we're going to go into our scripts folder, and I'm going to create under the managers, scripts managers, I'm going to right click, create C# script enemy manager. And once again, sit here and twiddle my thumbs while I wait for Unity to compile that script. And drag that onto our enemy manager component. And double click to open that up in the editor. Zoom in. Delete our boilerplate. And what are we going to do here? Well, one thing I want to do is create an event called enemy destroyed. The game manager is going to subscribe to this. Let's see. I want to do a new del. Well, let me fix this using statement. Now I can do this delegate. All right. And we want to have a public integer for the number of enemies remaining. And so now we need to have a list of enemies. So down here, I'm going to say read only list enemy input manager enemies. And we're going to use system collections generic for our list. All right, so now we have a list of enemies. Let's add some serialized fields. We want to have an array of spawners. And we want to have a spawn interval, which I'm going to default to 1 second. And down here, let's create a float for our spawn timer and an integer, which is going to be the index into our spawners. All right. So let's add a public void spawn enemies to spawn. And I'm going to use a coroutine for this. So I will say start coroutine spawn enemies with delay enemies to spawn. So let's create that I enumerator using the system collections namespace. Spawn enemies with delay int enemies to spawn. All right, so while enemies.count is less than enemies to spawn, we want to yield return wait 4 seconds spawn interval, and then we want to spawn an enemy. So basically going to spawn an enemy every second. And one thing I'm going to do is I'm going to take this and I'm going to call this spawn delay. And up here, can't be static. So let me actually, in our start method, say spawn delay equals there we go. All right, this way I'm not creating garbage every frame in here. All right, so what do we want to do in spawn enemy? Well, we want to say if our spawner is greater than our spawner's length. So what I'm doing here is I'm incrementing our spawner index, which we started out as -1. Actually, I'm going to start it here as -1. And maybe I'll just do this in here instead of start. I will say spawner equals -1. So I'm going to increment it so it becomes 0. If this is ever greater than or equal to spawners.length, then I will say that spawner equals 0. So it's just going to wrap around to the first spawner. And then I will return, and this is actually, I'm putting this in the wrong function. I wanted to create another function called next spawner. No. So in here, I'm going to say var enemy equals next spawner dot spawn enemy. Spawn enemy is returning void. Well, that's not right. Let's go into there. That's definitely not what I want. This should return a game object. And down here, I'm going to return enemy.gameObject. There we go. There, that's better. Okay, so now that I've got that, we want to set his transform parent to be our transform. So all of the enemies will be parented underneath of that enemy manager. And then we're going to add him to our list of enemies. Enemies.add enemy.get component enemy input manager. All right, so our list of enemies is a list of enemy input managers. We're going to get that component off of our enemy that we just instantiated. We're adding him to our list of enemies there. We're parenting him to ourselves. So I think this is all good. Now all we need is for the game manager to actually spawn these enemies. And this is never invoked, so that's fine for now. Let's go ahead and add a function here to remove an enemy and also to destroy all enemies. So right here, public void remove enemy, enemy input manager, if not, enemies.contains enemy input manager, return. Otherwise, we want to play the kill sound. We want to score points for killing enemy. We want to remove that enemy. We want to destroy that enemy's game object. And we want to fire the enemy destroyed event. And then let's add a function here to destroy all enemies. I'm going to call this from the game manager when the game is over, like when the player loses his last life, so that when we go to the game over screen, there isn't a bunch of enemies flying around. All right. So now we can actually go into that Joust resolver. So let's just do find object of type enemy manager. And if we have one, we want to say remove enemy input manager. So if we are an enemy, we're going to remove it. We're going to destroy this game object, and then we're going to return true. Just go look in there. Yep. Oh, that's going to destroy it here. So we can actually get rid of this destroy. That was what we put in there temporarily until we implemented this. Now, if we go up here to where we call this, this is actually wrong. If we're not removing an enemy, then what we actually want to do is we want to remove the player. And removing the player is going to be done by the score manager. So for now, I'm just going to say to do implement score manager dot instance dot kill player game object. But for now, we'll just say destroy game object, just like we did for the enemy. Okay, so we've got the basic logic here for if the player loses and if the enemy loses. Let's just go ahead and give that a quick test. Actually, we can't really test that yet because the enemy manager will not despawn the enemy because it hasn't spawned the enemy yet. We just dragged him into the scene. So we need to start working on our game manager and implementing the logic to spawn enemies, spawn players, and manage the overall game state. So the game state is mostly managed by the game manager, but I want to go ahead and create a score manager because I use the score manager to track how many lives the player has left, and that will determine whether we're going to spawn a new player or end the game when the player gets killed. So let me go ahead and say create C# script and call that score manager. And then Unity, of course, is going to have to think about that. But I'm going to go ahead and when it gets done spinning, I'm going to right click up here and say create empty and call that score manager. And then I'm going to drag that score manager script onto there. Okay, let's go into our game manager script and we'll zoom in. And we're going to do basically the bare minimum to handle the game state for when the player despawns and spawning a new player. So I'm going to take this guy and move him up to the top because this is a public function and I like to move them up above my Unity callbacks. And we're going to need a couple of serialized fields. We're going to want our enemy manager. And I could have made him a singleton, but in this case, I'm just going to assign it in the inspector. And we want to have a reference to the particular spawner we're going to use to spawn the player. All right. And so down here in our player mount despawned method, we're going to check to see if we have any lives left. So we're going to say score manager dot instance dot lives. It's greater than 0. Then we are going to say player spawner spawn player. Now, there's a couple of problems here. Our score manager currently is not a singleton and it doesn't have a lives property. So let's just hit F12 to go into there. And basically what I'm going to do is I'm going to derive from that singleton mono behavior. And we're going to make that a score manager. And let me go ahead and get rid of these boilerplate things. Do the same thing with our using statements. I actually am going to need system. All right, so we're going to eventually have a effect prefab for when you collect an egg. So I'm just going to put a to-do up here. And we want to have a couple of events that the score manager will fire. So I want to have a public event action, and that's why I needed the system namespace. Integer on score changed and on lives changed. And you know I like to make these empty delegates so I can invoke them without getting any errors. And then we're going to have some public methods, or not methods, but properties as well. So I want a public static, and I'm making this static because I want this score to persist after the scene loads. Well, after the game over scene loads. So when we switch from the game playing scene to the game over scene, I want to display the score on the game over scene. So I want to make this static so that I can access this even from the other scene. So we're going to make that a public getter and a private setter. And I could have made this singleton, I could have added don't destroy on load on it, but then I would have had to move it to the root of the hierarchy. And I'm just going to make this one property static so I can access it outside of this scene. We're also going to want to be able to see how many lives we have. And that should satisfy that compiler error that we were getting in the game manager. And I want to add some serialized fields. I'm going to move this to do down below these. And let's add another serialized field here. A few of them. We're going to have the number. Well, I want to have the number of points that you get for collecting an egg. So I'll say egg value is 250. The number of points you get for killing an enemy, I'm going to say 500. And then you get an extra life every 20,000 points. All right. And then we're going to have a couple of local variables for the number of enemies killed and the next extra life at. All right. So some public methods for our score. I want to be able to reset the score. So how about public void reset score? And I think I want some additional variables here. I want to have the wave that we're on. And wave, think of wave as a level. So in here I want to set wave to be 0. I want to set lives to be 3. I want to set score to be 0. I want to set our next extra life to be our extra life interval. I want to invoke the on score changed event with our score, and I want to invoke the on lives changed event with our lives. Did I not declare that correctly? I did not. All right, on lives changed. And then I'm going to have a function called next wave, and really I think all I'm going to do in there is increment the wave. But if I want to do any extra functionality in here, it'd be nice to have it in its own method. Boy, I cannot type a plus sign to save my life. All right. All right, I want to have some methods for scoring points for different things. So I want to have a, since that's private, I'm going to put that below the other public methods. So I'm going to come up here and say public score, public void score egg. And since I'm going to display an effect at the position of the egg, I want to take that egg's position as a parameter, and I want to play the egg sound, and I want to add points, so that's going to be another new function we need to add, egg value. So I'll hit Alt Enter, create that function. I'm going to move it down into the file below that next wave. So add points, we're going to say that score plus equals whatever points were passed in, and of course I called that egg value. I want to call it points. It's the problem with letting it auto generate stuff. It doesn't always name things correctly. I want to fire the on score changed event with our new score. And then if our score is greater than or equal to next extra life at, then I want to call gain life. And we will create a function for that. So in gain life, we are going to increment our lives. We're going to set our next extra life at by adding our extra life interval to it. And we want to say on lives changed with our current number of lives. All right. I think that's all we need for gain life. I want to add a public method for killing a player. I want to take our player object, and I want to play the kill sound. I want to destroy that player, and I want to call lose life. All right. Alt enter, create method, lose life. And in there, we're going to decrement our lives and call, on lives changed with our current number of lives. The only other thing I think I need is just the ability to score a kill for when you kill an enemy. So our sound manager dot instance play kill sound. I'm going to use the same sound whether you're killing the enemy or he's killing you. We're going to add points and I'm going to increment the number of points we get for every enemy we kill. So I'm going to say enemies killed, increment it, times the kill value. And that will get reset when we start a new game. So I want to add that in here too. So enemies killed equals 0. Actually, I probably want to reset that every wave. Now that I think about it. Otherwise, your scores will go up incrementally. Yeah, that should do it. So let's go back into our game manager and flesh out that logic. So let's scroll down here. What do we want to do in start game? Well, we want to reset the score on our score manager. We want to subscribe to some events. So I'm going to actually do that in another function. This kind of helps make my code be self-documenting. And we are going to want to start a new wave of enemies. And then in on destroy, I'm going to move this up here. I want to unsubscribe from events. Okay, so let's come over here and hit Alt Enter, create new function, subscribe to events. And we're going to subscribe to the score manager's instance on lives changed event. And we're going to call this on lives changed. Alt Enter to create that. And we want to tell our enemy managers enemy destroyed. We're going to handle that event in our own on enemy destroyed function. Go ahead and do that. And I'm going to move this down below the other one. Okay, now we have subscribe to events. Let's do unsubscribe from events. So we want to take score manager.instance. Let's just copy and paste this. And make sure I remember to change the plus to minus. There we go. All right, so in on lives changed, we want to say if lives, and I want to call this parameter lives. So if lives is less than 1, we want to tell the enemy manager to destroy all enemies, and we want to load the game over scene. Make that a to-do. In the meantime, I'm just going to say debug.log game over. All right. And on enemy destroyed, we want to say if enemies.enemies remaining is less than 1, next wave. All right. Let's create the next wave function. And I also want to have a start wave. Do I already have start wave somewhere? I do not. So let's go ahead and create that above here. So start wave, we will say enemy manager dot spawn enemies score manager dot instance dot wave times 2 plus 1. So I'm going to spawn whatever wave we're on, 2 enemies per wave, plus 1 more. So I think on wave 1, we'll have 3 enemies. On wave 2, we should have 4 enemies, or 5 enemies. Wave 3, we should have 7 enemies, and so forth. So our score manager, if I can get my fingers on the right keys, score manager.instance.next wave does not exist apparently. And our enemy manager spawn enemies score manager.instance.wave times 2 plus 1. Actually, I think what I want to do here is call start wave, since I've already got that logic in there. And let's go see what's up with this. It needs to be public. So let me move this up to the top. That's good. Control minus, go back to the game manager. Get rid of these unused directives. All right, I think that's probably pretty good for now. I'm trying to see where we're going to spawn a player. We do that in player mount despawned. All right, I think that's looking pretty good. So let's jump back out into the Unity editor. And we'll take a look at our game manager. We want to drag our enemy manager into that field there. And we want to pick one of our spawners. So this one here I think is a good one. So once again, select our game manager. Let's see, that's the top one there. So take our game manager and then drag this top spawner right into there. And I want to jump back into code and I want to look at our to-dos and see what we got left here. So we want to score points for killing an enemy. So we can say score manager.instance.score kill. All right, so there goes that one. We want to load our game over scene, so we should go ahead and create that. And then here in our Joust resolver, score manager.instance. What's it? Kill player. There we go. Kill player. And is it this? Game object. All right. That looks good. And it looks like Ryder is suggesting that I invert that if, just to reduce nesting. Okay, so we're down to that to do, and then we need to add our egg collect prefab and instantiate that. We can definitely do that later. But I think it would be a good idea to go ahead and create our game over scene. So I'm going to jump back into the Unity editor. And I'm hoping you can see there how adding those to-do comments is useful to go through and not let things fall through the cracks. All right, so going into our scenes folder, I'm going to take our title scene, select it, and hit Control D to duplicate. And then select Rename and call that Game Over. And I'm going to double-click that to open up that scene. And so we've got our nice Joust logo there. And I think what I want to do in here, I know I mentioned I want to display the score. So we expand this here. Instead of saying tutorial title, I'm going to say Game Over. And I'm going to just change this text to be Game Over. And I want to make that quite a bit bigger. So we go down to our font size and say 120. I think that looks pretty good. We got press flap to play. And I think I'm going to rename that to play again. And down here, I'm going to say press flap to play again. All right, so that looks good. I'm going to duplicate this, move it up, and I'm going to call that score heading. And I'm going to call that score. And I don't think I want it to be that big. So I'm going to reduce that back down to 72. Let's double click it to select it in the scene view so I can grab it and drag it down. And then duplicate that. And that will be our actual score. And I'm just going to give that a default value of 6 zeros so I can see how it would look. And drag that down about like that. And we will, of course, add a script to that. So like, for instance, right now we have a title screen. I'm going to remove that component. So if we go into our scripts UI, I'm going to create a new C# script and call that game over UI. Select our canvas and let that recompile. And drag that script right onto there and double click to open it up in the editor. Zoom in, get rid of the boilerplate code. We're going to have our serialized field for our Text Mesh Pro, which is going to be our score. Select that, import the missing references, which added that using TM Pro. Delete those. I also want to have our input manager. So input manager base, input manager, and then a nice little helper property here, input manager, which is just going to return that input manager.input manager. All right, in the start method, we want to set our score text to be score manager dot instance, no, it would be dot score. So you remember that I made that field, that score field, a static, a public static, so I can access it from anywhere and I don't have to go through the instance to do it. All right, and I want to subscribe to the input manager's on flap pressed event, and I will go ahead and create that function. Go in there and delete that, and in here we will unsubscribe from that event. Change that plus equal to a minus equal, and then we're going to load scene. Oh, scene manager.load scene game, and I'll set the mode to be single and get rid of that. All right, going back out into the Unity editor. We now have a game over scene. Let's go ahead and drag our fields into here. First of all, we want to add well, we've already got a player input manager. Good. So I'm just going to drag that right up into here, down into here. And then we're going to drag this score field right there. And that should be all we need for the game over scene. So let's switch back to our game scene and go back into that script that we were looking at, and then look at our to-dos. And so right here we just want to say scene manager.load scene game over, and that's not going to work until we add that to the build settings. So you see we got this little squiggly here warning us the scene is missing from the build settings. So let's go back into the Unity editor, let that recompile, edit, or actually it's file, build settings, and then we want to take our game over scene and drag that right into there. Okay, I think I'm at a point where I want to give this a test. I want to delete that enemy from the game. And I want to start out on our title scene and hit play and see what happens. All right, press flap. We're not spawning any enemies. I see I have an index out of range exception in our enemy manager. So let's go take a look at that. We need to switch back to our game scene. Managers, enemy managers, and we haven't assigned any spawners. So I'm going to right click on this and say properties. So I get a window here that even when I check different things in here, we're not going to change what's in the inspector here. So under platforms, we want to see all of our spawners. So I'm going to expand all those. And I'm just going to hold down Control and multi-select all of them. And I'm just going to drag all of them right into our spawners. Just like that. And we can go ahead and start in our game scene. I think the way I've architected it, I can start in the game scene and it should work just fine. And look, we're spawning enemies. I need to collect eggs. We're not doing that yet. Looks like let them on the I can't lose. There we go. So my guy will fly off the screen, and we should spawn a new player. If you're not spawning a new... you know what? I think he probably changed direction before he reached the boundary. And so he never told the game manager to spawn a new player. So something weird's going on there. We're going to have to do a little bit of debugging to figure out what's going on with the player spawning. But it looks like the basic gameplay is working. So one thing I want to look at is the position of that despawner. If we go and look at our prefab and click our player mount, this boundary here is set at 7, and I'm not really sure. That might be too far off the screen, and if he changes direction before he gets there, he might come running back on the screen and not spawn. So let me take a look at that value. I want to grab our player and look at his position here and just maybe just move him a little bit and look at that X value. Well, 7's actually not a bad value. So I'm not really sure what may have happened there. I might have to put in some debugging. I do have a debug log statement here saying despawn mount. And that's called whenever our Y position... Oh, our Y position. Well, there's a problem. That should be X. Okay, so there was a definite bug. Another thing I might want to do, and we'll just see how it works. We'll play around with it. But that should work fine. I was wondering if maybe if it was possible he could fall off the edge. Like if he went out past this collider and fell, and then I could check to see if his Y position was less than something. But I don't think he should ever get that far. He should definitely despawn if he gets a little bit farther than this. I'm not 100% sure too if the bird I saw spawn here was what looked like an enemy but was supposed to be the player. I'm really not sure. So one thing I want to do is I want to go into the spawner and I want to put a log statement when we spawn a player right here. I just want to say debug.log spawning player, and down here debug.log spawning enemy. So there's lots of ways to debug. You can put log statements in there. I could actually put a breakpoint in here and attach this to the Unity editor, and I could use the debugger to debug, but then I would hit this breakpoint every single time I spawn an enemy. I just want to see in the log what my execution path is. So I'm going to hit Control S to save that. Jump back into the Unity editor and hit play. And let myself get killed and see what happens. Oh, I don't even need my player over. I'm stuck. It's executing the logic to teleport me over and over and over again because I started in a weird place. Let me just move him about there. Hit play. Let him kill me. Yeah, that for some reason spawned an enemy. So that definitely seems like a bug. So let's look at that And actually, I want to go back and look at the call stack and see where that was called from. It's called from the game manager. Yeah, just a typo. Spawn player. Let's give that another try. Trying to switch back to the Unity editor. There we go. It took a while. Hit play. And there's another new player. Didn't look like the mount switched to the running animation when it was grounded. Might have to look at his raycast interval. To kill me. There we go. Game over. 1,500 points. Press flap to play again. Alright, so I'm thinking that the basic logic there is working. A couple little tweaks I want to make. We need to implement the egg collection, and then I want to work on the UI. So for egg collecting, we're going to go to our player prefab. Collapse these. We want to add a new script to him. So let's go into our scripts folder, right click, create, C# script, and we will call this egg collector. Let it recompile. All right, select our player and drag that egg collector script onto there, and then double click to open that up in the editor. Go ahead and minimize that window. Get rid of this boilerplate code. And what do we want to do in our egg collector script? First of all, we want to handle on collision enter 2D. And like always, I like to rename this parameter here to other, because I'm colliding with something other than myself. And for debugging purposes, I'm going to add a log here. I'm going to say egg collector dot, actually I'll just say name, collide it with other dot collider dot game object dot name, just so I can see in the console what it was I collided with. And I want to say if is egg other out var egg. In order for that to work though, I need an egg class. So I'm gonna come down here and say public class egg, type mono behavior, and that's all I'm gonna have for now. What is it complaining about? Let me just see if I can move this to another file, if it will stop complaining. Oh, somehow I created two. Maybe I already created that and I forgot. I don't know. But control minus, go back into here. And so what I'm going to do in isEgg, I'm going to call this out egg egg. Say that egg equals other dot collider dot game object dot get component and parent egg. And again, the reason I'm checking in the parent is because the colliders are on child objects usually. So I want to make sure I look in the parent for the actual component here. And I'm going to return that. Return egg. So if egg is not null, that will return true. And I'll have it in my out parameter here. So if the thing we collided with is an egg, then I want to collect the egg. Hit Alt Enter, create method, and I'm going to move that down. Otherwise, else if is night. So this is a case where after the egg is hatched, it could be if after it's hatched, it's going to be an enemy knight. And if it's an enemy knight, I want to score points for that as well. So I'll say other out var knight collect egg knight. All right, so I actually want this to be a component, not an egg. And I guess I can call it egg even though it's technically not an egg. So in here, I'm going to say score manager dot instance dot score egg dot transform dot position. And then I'm going to destroy the egg or the knight, whichever it may happen to be. So is knight, let's say out enemy knight. So once again, public class enemy knight of type mono behavior. Move to enemy knight.cs control minus. So is knight. We'll say that knight equals other dot collider dot game object dot get component in parent enemy knight return knight. So if it's an egg, we're going to collect the egg. If it's a knight, we're going to collect the knight. Collect egg doesn't care. I'm just going to rename this to collect just to avoid confusion. I'll say collect component, and I'm going to call this pickup. It doesn't really matter. It's just I'm trying to avoid confusion. This says score egg. All right, I'm going to rename this too. I'm going to say F2 to rename and say score pickup. And I'm going to go to this definition and I'm going to rename that. Let's see, F2 pickup value. And it's warning me because I changed the name. If I had assigned a value to this in the inspector, I'd have to go reassign it because I renamed it. I could optionally add an attribute to it saying that it was renamed, formerly known as, but I'm not going to do that because I never assigned anything to that in the inspector. Ultimately, we're going to add a prefab for an effect, and the effect is just going to display the number of points that we scored by picking that up. Is there anything else we need to do in there? We need to actually add those scripts, the egg script and the enemy knight script, to those prefabs. So let's jump out here and go take a look at our egg prefab. Oh, I've already got that one there. Nice. And then we need to create a prefab. Well, we actually need to create an enemy knight. So if the egg hatches, we're going to create an enemy knight and it will have the enemy knight script. But let's first test that I can pick up eggs and score points for them and have them disappear. Catch them. Oh, I picked the egg up before it ever hit the ground. Ooh, that one rolled off the screen. I need to add the teleporter script to the egg. Alright, so I am picking it up and I am scoring points. I want to take our egg prefab and I want to add the teleporter. So if it rolls off one side, it will come back in the other. Next thing I want to do is I want to create the enemy knight prefab. So I'm going to get out of that prefab. I'm going to right click here, create empty, call this enemy knight. And I'm going to add component enemy knight. And that script is an empty script that doesn't do anything. It's just going to let get component work. I'm going to drag that into our prefabs folder. And I'm actually looking at this. Let me look at this prefab. Yeah, so the sprite's going to live underneath of it. I just wanted to make sure I was doing what I thought I was doing, and that script should be get component and parent. So I'm going to add under here a sprite. So 2D object sprites square. And I'm going to expand that and go into our art folder. Let's zoom in here a little bit and scroll down until we find that red standing knight and drag that up into there. And that looks a little small, so let's make him bigger. And I think that looks pretty good. The other thing I'm going to do is add a box collider to him. So down here, box collider 2D. Zoom in on that in the inspector. Resize that a little bit. All right, so I think that is our enemy knight. I will override to apply that to the prefab. And I will delete that there. So now let's go and look at our egg prefab. We have this egg script, and it currently does not do anything. So what we want the egg script to do is basically hatch into an enemy knight. So add a couple of serialized fields. We want a float for hatch time. And I'm going to say 5 seconds. We want a serialized field for the animator. Animator, you say? Why? Well, because we're going to have a little animation that plays when the egg is hatching. All right, so have a variable here for hatch timer. And I want a static read-only hatching, which is going to be our string to hash. Hatching. We're going to use that to set the animator state for when he starts hatching. So in our start method, we want to set our hatch timer to be hatch time. All right, our update method, we're going to say if we don't have an animator, then return. Otherwise, our hatch timer will be decrement time dot delta time. This should be minus equal. And if that is less than or equal to 0, then we want to take the animator's bool for hatching and set it to true. Oops. And let me go ahead and get rid of that unused directive. Let's jump back out into the Unity editor. Let that recompile. So in our sprites and animations here, we want to take our egg hatching sprites and we want to drag them into that folder. So let's see. We want to drag these 3 images into this sprites and animation. That's going to create a new animation. So let's navigate to our animations folder, into the eggs folder. And what do we want to call that? I think we just want to call that hatch. Make sense? Alrighty. And I don't want that to be particularly fast. So we pick that and we select this hatch and we hit play. That's really fast. So I'm going to change this to 4 samples. Oop, looks like I did not save it. That looks better. Okay, cool. So the other thing, if we go into that animations folder, it called our controller Sprites. Again, Sprites and Animation Controller. If I zoom out, you can see that. So I'm going to rename that to Egg Animation Controller. And we'll go ahead and double click that. so we can see this in here. So we have this state here, which is hatch. We actually want to create basically an empty state that does nothing. So I'm going to say create state empty. I'm going to rename that to be idle. What in the world did I do? Idle. Why in the world is it renaming it to 4 when I hit enter? Okay, let me just hit Control Z and leave that like that. I'm going to say set as default layer. We want to add a parameter here. It will be a Boolean, and I'm going to call it hatching. And we will have a transition from there to there where hatching is true. I don't want an exit time. I don't want it to have any fixed time or transition duration. The other thing I want to do, though, is I want to make sure I turn off loop time on this animation because I don't want it to loop. I just want it to play through once, and then he's going to hatch. So how are we going to hatch? Well, we want to add an event on the last frame. Actually, I want to add it out here. And so we will select that, and we need to have a function on here to hatch a night. So that means we need to create another script in here, and I'm going to say create C# script. Where did it go? Create C# script. There we go. And I'm going to call this hatch. Double click to open that up in the editor. Zoom in. Delete the boilerplate. Add a serialized field for the prefab, which will be our enemy night prefab. Public void hatch night. Instantiate enemy night prefab at our position. Transform that position using quaternion identity for the rotation. And then we want to destroy the egg. So we're just going to say destroy game object. All right, get rid of this unused directives, jump back out into the Unity editor. And we're going to select this sprites and animation node here and drag that hatch script right onto it. So now if we select this event, I can select hatch night. All right, so let's just hit play. See if I can kill a bird and just wait and see if the egg hatches. 1,002, 1,003, 1,004, 1,005, 1,000. Does not seem to be hatching, does it? So I'm guessing we don't have our animator selected. Let's go to our egg prefab. We never assigned our animator. So double click this to open it up here, select this, and we will drag our animator. Oh, that's the prefab. Well, we need to do that too. But for here, we're going to drag our animator into here. And then for here, we need to drag our enemy knight into the prefab. So we forgot 2 steps there. I've been doing this a long time, and I still forget to do simple things like this. Let that egg hatch. And there he goes. He hatched. I think I need to turn off. I want to freeze rotation on that egg because you saw the way it was rolling. And it also seemed to be on the wrong frame for that egg. It didn't seem to be showing the spherical. It also seemed to be on the wrong frame for that egg. It didn't seem to be showing the spherical value of it. In fact, that may be why we saw it rolling like that. Let me go back and look at the egg and look at his sprite renderer. So sprite 65. That does look like the correct one. It doesn't seem round. It seemed like it was kind of rolling. I wonder what I can do to make it look more round. But at any rate, one thing I think I can do is take his rigid body and freeze his rotation. See if it animates and then hatches. Yep, boom. Alright, now I should be able to collect them for points. Oh. Can you guess what the problem is? I'll give you a hint. It has to do with the collision matrix, which has to do with the layer. If we go to our enemy knight, double click on that, we need to put him on the enemy knight layer and all his children. Let's go ahead and give that another test. Oh, I collected the egg. Oh, I collected the egg again. And again. Okay, I need to let an egg fall. There we go. 1, 2, 3, 4, 5. He hatches. If I can get past these guys. And I collect them. Alright. So the next thing I think I want to do is the egg collect effect prefab. And then we're going to start working on our UI. So getting out of this prefab, I'm going to right click here, create empty, and I'm going to call this egg bonus. All right. And we're going to have 3 sprites underneath of this. So I'm going to say 2D object sprites square. And in our art folder, zoom in again. And we're going to go down to those alphabet things here. So what we want is basically to show 2, 5, 0. So I want to drag the 2 in here. And then I'm going to rename this to TWO. All right. And then I'm going to duplicate that. Rename that to 5. And I'm going to drag the 5 into there. And I'm going to move this on the x-axis up a little bit. Let me zoom in on that in the scene view. So let's take the 5 and just drag that to the right a little bit. I think that looks pretty good. And then we're going to duplicate that and rename that to 0. And we're going to drag this sprite into there. And move him over. I think that looks pretty good. I think I want the whole thing to be a little bit bigger though. So maybe 50% bigger. Oh, I'm on the wrong node. I want to select the parent. 1.5, 1.5. That looks pretty good, but I do want the color to be yellow. So I'm going to pick all 3 of these, take this little eyedropper, and take that yellow color off of the knight. All right, so now we have an object with 3 sprites under it that's going to display our bonus points whenever we score an egg or a knight. Now I want to create a script for that. I'm going to put it in the UI folder. Create C# script, and I'm going to call that egg collect effect prefab. Well, I'm just going to call it egg collect effect. Select our egg bonus, let Unity recompile, and I'll drag that script onto there and double click to open that up in the editor. Get rid of our boilerplate and add serialized fields for those sprites because we're going to actually fade them out. So I want to get their renderer. So a serialized field, sprite renderer array, and I'm going to just call that renderers. And I want to have a couple of floats for our fade duration, which I will default to 2 seconds, and our fade delay. So I want to wait a little bit before I start fading it out. Not much, maybe a second. Now I'm going to show you a little trick here. The start method can be a coroutine. And the way you do that is you, instead of declaring it as a void, you declare it as an I enumerator in system collections, start. And again, if I hover over this, Writer will tell us that start is called on the frame when a script is enabled just before any of the update methods are called the first time. This function can be a coroutine. So that's what we're doing here. And what we're going to do in here is we're going to do a yield return, new wait for seconds, and we're going to wait for our fade delay. And then after that, we are going to get the initial color from, we'll get it just off the first renderer. Renderers, position 0, .material, .color. So we're saving our initial color in a variable called color. And while our color is alpha, in other words, how opaque it is, while that's greater than 0, we're going to loop indefinitely. And we're going to say for each renderer, so for each var sprite renderer in renderers, so we're going to loop through all 3 of our renderers. We're going to calculate a fade speed, basically taking into account our fade duration and the current time. So we're going to say var fade speed equals 1.0 f divided by the fade duration. And we're going to set our colors alpha. We're actually just going to decrement it by the fade speed times time.delta time. So we're basically doing a percentage here, and we want to smoothly fade it out over our fade time. So we're going to assign that back to our renderer. And then we also, in addition to fading it out, we want to move it up and to the right. So we're going to say transform position plus equals vector 3 dot up times time.delta time, and transform position plus equals vector 3 dot right times time.delta time. Oops. Time.delta time. And we're going to do a yield return null until the next frame. So every frame we're going to just fade it out a little bit and move it up and to the right. And then when all that is done, once it's completely faded out, we are going to destroy the game object. All right. Going back out into the Unity editor, and we want to go up to our score manager and open this script here. And so we have this to do here for our add egg collect prefab. So add a serialized field here and call it egg collect effect, and we're going to call this egg collect effect prefab. All right. And then when we score an egg, we want to instantiate the egg collect effect prefab at the egg's position using quaternion identity for the rotation. And that should do it, except we don't want instance, we want instantiate. Jump out to the editor and assign that prefab. Okay, so score manager, take this guy, we're going to drag it into our prefabs folder. There it is. So take our score manager and drag that prefab into there. Let's go ahead and give that a little bit of a test. Oh, delete that from the scene. Don't need it. Hit play. should fade out and go up to the right. It is not. Oh, I know why. See these errors here? We did not assign, well, I'm going to let you guess. What do you think we didn't assign? If you guess that we did not assign our renderers, you would be right. So let's double click this to open it up. And then we're going to drag that guy, and that guy. So now we have 3 renderers, 2, 5, 0. Go ahead and give that another test. And there it goes. It fades out and moves up and to the right. I'm happy with that. And I think the very next thing we're ready to do is to add our UI. So let's jump out of this prefab, go into our UI here, and we're going to create a canvas. And we're going to go into here, and this is all fine. For our canvas scaler, we want to change it from constant pixel size to scale with screen size, and we want to use the same dimensions that we're using here. So 1301 by 979, that should be good. And under here, we're going to create a scoreboard. So I'm going to say create empty. Actually, yeah, I'm going to create an empty and call that score board. So we get a nice rect transform. And we're going to add a script to that. It's going to be called scoreboard UI. So down here in our scripts UI, create C# script scoreboard UI. Let Unity think about that for a second. I'll drag that right onto there. Now we want to create a couple of TextMesh Pro text fields under here. So first, down here to UI, TextMesh Pro, and we're going to call the first one score. And we're going to dock that down to the bottom here. And we, of course, want to use our arcade font. And for our color, we want to use the yellow from that guy right there. And let's change the pixel size to 48. And this one we want to right justify and use the cap line for there and turn off wrapping. And let's default it to a value of 0.00000 and use the move tool to move this down and left to about there. Now we're going to right click here and say create empty, and we're going to call this lives. And for lives, we're going to add a horizontal layout group, but we also want to anchor that to the bottom. So horizontal layout group, and we're going to change this to use child scale. And we're going to create a couple of prefabs, or we're going to create a single prefab rather, for the player life indicator. And the player life indicator is basically just a little sprite. So all we're going to do is right here, 2D object, actually want UI, image. And then for this sprite here, we can actually just select this right here and then scroll down until we get into that sprite sheet. And we're going to look for that little player life indicator, which is this guy right here. And that, of course, is way too big. Let's change its width and height to be 25 by 25. All right. And if we were to duplicate that, you see we get 3 of those nice little guys. And one thing we want to do is we want to change, we don't want those to go left to right. we want them to start on the right and go left. So right here for our child alignment, we're going to say middle right. All right, so now if we were to delete one and delete one, you can see that they appear from the right and they grow out to the left, which is exactly what we want. And so we're going to take our little move tool here, select the parent, drag that down a little bit, drag him over to the left. And I think I probably want to go a little farther to the right and just down a tad more. There, we've got our player life indicators. I'll delete these two, and then we're going to create our prefab. And I'm going to rename that to be Player Life UI. And then I will delete that. Good, so going into our scoreboard script, we'll zoom in there, delete our boilerplate, get rid of the unused directives, and we're going to start working on our scoreboard script. So serialize fields first. We want our TMP text field for the score. And once again, we need to import the using statement. So using TM Pro. We want to add a transform for our lives. So player lives container. And then we want to have a game object for our player life prefab. Okay, so now on our start method, we want to subscribe to the events on our score manager. So score manager.instance.onScoreChanged plus equals onScoreChanged. Score manager.instance.onLivesChanged plus equals onLivesChanged. And we will create that method. Change that to lives. Create that method. Change that to score. All right, and then we want to add an on disable where we will unsubscribe. Whoops. On disable. All right. And I'm going to copy these, paste them, and then change the plus equal to minus equal. And we want to create a new function here called remove extra player life icons. And I'm going to hit Alt Enter to create that method. Okay, so what we're going to do in remove extra player life icons is we're basically going to remove any of those player life UI elements from the transform that are more than the actual number of lives. So the way that we do that is we get the child count from our transform, from the child player lives container transform. So we're going to say child count equals player lives container dot child count, and then we're going to say while child count is greater than lives, and so we passed in the number of lives, and so when we're disabling we don't want any lives, so we're going to get rid of all of them. So while child count is greater than lives, we want to destroy player lives container player lives container dot get child count. We're going to decrement it first. Dot game object. I don't want get component. I want get child. Man, autocomplete really messed me up on that line. Okay, so ignoring all that autocomplete nonsense, we're taking the first child. Well, we're taking the child at this position. So say there were 3 children. So lives would be 3. So we're going to decrement this down to 0, 1, 2. So we're going to get the last child, and we're going to destroy his game object. And we're decrementing it before we do that. And then we are going to return child count. And this needs to be an integer, not a void. Okay, so let's add another function to add missing player life icons, taking the number of lives and our current child count. And while child count is less than lives, then we are going to instantiate a player life prefab, and we're going to parent it to our player lives container. And we're going to increment child count. All right. So now in onScore changed, we want to say score.text equals score.toString. And in onLives changed, we want to say child count equals remove extra player life icons, passing in lives, and then we want to add missing player life icons, passing in lives and child count. So if we had too many, we're going to remove them. If we didn't have enough, we're going to add them. And that will update our scoreboard, both the score and the player lives, every time the score changes and every time we either lose a life or gain a life. So going back into the Unity editor, we need to assign these variables. So after Unity recompiles everything, okay, we're going to move the score field into there, our player lives container into there, and our player life UI prefab into there. So we've got 0, 0, 0, 0, 0 right there. Let's go ahead and hit play and see what happens. All right, we got 3 lives. Oh, we lost a life. Oh, we got 750 points. Okay, let's die. We're down to 1 life. And there it is. Game over. 10,500 points. Play again. We have no points and 3 lives. All right. Excellent. I think the final touch is I want to create an exit on quit script. So right here, create C# script exit on quit. And we're going to put that on our game manager. Drag that on there. Double click to open it up. Zoom in. In our start method, actually I want to add a variable here called player input manager. Player input manager. And in start, I want to say that player input manager equals find object of type. If I can put my finger on the right keys, player input manager. Now I could very easily have made that a serialized field and dragged that in, but I'm just showing you another way to do it. And then I'm going to subscribe to the player input manager dot on quit pressed, and I'm going to create a function called quit application, and I'm going to get rid of this update here. I'll enter create method quit application. Now I'm going to show you how you can exit the application both in a standalone build and within the Unity editor. This won't work quite right on a mobile device, like on an iPhone. It'll close the application, but it will still be running in the background. So what we're going to do here is we're first going to unsubscribe from this event. So copy and paste that and change that to -equal. Now we're going to add what's called a preprocessor directive. #if, that's what identifies it as a preprocessor directive. Unity editor. I'm going to say else end if. I guess I'll indent this since it seems to want to indent it anyway. And in here I'm going to say Unity editor dot editor application dot is playing equals false. It unindents it. I just think that's hilarious. Okay, so yeah, so if we are in the editor, we're just going to tell it to stop playing. We don't want is paused. I think I did this in my last video too. Stupid autocomplete. Is playing. All right, so now if we are not in the Unity editor, we're going to call application.quit. And you can see that this is grayed out because right now this knows that we're basically in the editor. If we were to actually do a build, a standalone build, this would be compiled and this would not. So this preprocessor directive tells the compiler which of these code blocks to compile. All right, I also want to add this in our title scene and in our game over scene. So let's go over here to scenes and go to title, save that scene. And we're going to go up here and we're going to click this canvas, which has our title scene, it has our player input manager and all that. And we are going to add exit on quit and hit Control S to save. And then I'm going to go to the game over scene, pick that canvas object, add component, exit on quit, Control S to save. So let's go back to our title. I'm going to hit play and I'm going to press the X button and see if we don't quit the game. And there it goes. All right, let's go and press the flap key to start playing and then try and quit the game. Yep. And you can take my word for it. It will also work on the game over screen. Well, I think I'm going to call it a wrap for this video. It's already getting pretty long and I don't want to go much longer. And I know we haven't implemented the entire game. There's some things I left out, but I've given you the basic building blocks. All the basic gameplay is there. You can start a game. You can play through several levels. You can go to the game over screen and play again. And I'll leave it to your imagination to see how you could add the pterodactyl or have the enemy birds pick up the enemy knights and become fresh enemies to fight. And if you have any questions about anything I covered in this video or any suggestions, leave a comment down below, or better yet, go over to my Discord channel. I'll be sure to leave a link in the description. You can put any detailed questions you have there along with any screenshots or code snippets, and I'll do my best to respond to them as soon as I can. And speaking of links, I will put links to all the source code for this tutorial as well as the assets that I used in the description as well. And if you found this useful, and I really hope you did, do me a favor. Click that like and subscribe button. As you can imagine, it takes a lot of time and effort not only to make a game like this, but to make a tutorial to teach you how to make a game like this. And I could really use the incentive to keep making videos by seeing that you support my work. So again, click like, click subscribe if you haven't already. And if you really feel so inclined, you can go over and buy me a coffee. I want to make you aware of my upcoming Steam release for my real-time multiplayer cross-platform game Highland Panic. It's a card game that's based on Dutch Blitz, but with a Highland Scottish feel. And I'm using Unity's netcode for game objects, lobby, and relay. And I'm going to be starting a series of devlogs for that project pretty soon. So be on the lookout for that. So you can click that notification bell to be notified when those videos go live. So finally, thank you so much for watching. If you stuck through this whole video, I applaud you. And good luck on your game development journey.